teams, you need to explore different avenues, and some things sometimes they don't make much sense. Like as Theo says, stuff like the hydrogel and playing with them and how they accumulate water and stuff like that. This is interesting experiments by themselves. They're not gonna necessarily be your system as such, but it's part of your system. And the more of those explorations you do, the richer the system gets and more coherent at the end of the story. Don't expect that in day one we expect that you're gonna have a system that is, operating. But starting, exploring parts of it, like baby steps, is key. And that's where prototypes actually, they are fundamental on that. Because if you see them in isolation, they may not make sense at all, but you need to see as part of a bigger picture. And
yeah, the thing is, I mean, you should think about it almost like, let's use cinema as an example or a reference. Each of these kind of little experiments is just trying to capture an element and to communicate it, and also make that legible to other people. And as you're sort of collecting these experiments, the behavioral aspects that you will engage in, both digitally and physically, are going to shape a kind of intuition. The narrative becomes clearer once you start to see some of these things in formation. And this interesting aspect, I think, about this studio is that there's never always a one-to-one correlation with what we're looking at. So these experiments are really like not just to inspire you or just to gain a bit of knowledge. It's really to question fundamentally also what we consider the mediums that we think about in terms of the built materials that we use to create our architecture. But it's also, I think, fundamentally to gain an intuition about how behavior works and how people can kind of engage in that. And that's why we think about certain concepts of autonomy. Our architecture is not always really about control in an explicit way, like a robot controlled to do this and that. It's more about how the systems are responding to changing circumstances. That's where we speak a lot about adaptation. Adaptation is really a concept which is very different than normal ways of thinking about things, because you cannot always know what is coming in the environment, but you design a system that almost self-regulates itself to be able to incrementally change. So it's really about how your architecture evolves and takes information and how it processes that information. And that's why the projects aim to be much more symbiotic. So I know that we're using a lot of language, but I think the language in our studio is very particular. And the way that we work on it, when I say messy, is not just about making literally messy experiments. It's really trying to open up the way that we
In this tutorial, we will...
I think we have to, in this term, force the issue about what really architecture is. I use the example of the hydrogels with Apo because, we've had other projects that tried to do stuff with hydrogel. Hydrogel by itself is not a project, but, just basic qualities of using some materials also speaks to the fragility of some of the phenomenon. Or, for example, how long something like a hydrogel retains water, how slow it releases water, how invisible it is when it is in water, how translucent and, optically kind of definable it is as these kind of, loose spheres, and the kind of material effects that actually has perceptually. So we try to extract different ways of looking at things. And some of these things can be done at home very easily, like simple experiments with some of this stuff. So it's not really about, using a big robotic manufacturing kind of toolkit. In our case, it's a little bit more anarchic. When we speak about, let's say in this context, elemental, it means that these things are everywhere and around us, you know. So I think we should try to think about strategies that we can do wherever the context is that we find ourselves, potentially to engage in this a bit further. And I think as soon as you do that, there is an interesting paradox that emerges immediately. Means like your particles and your voxels and stuff like that will have to be kind of quite clear. What's the connection between the physical manifestations of some of these experiments and the indexical relationships that you have in some of these simulations? What is a voxel in a growth algorithm? Is it something that evolves, or is it a notational system that we need a technique to translate? And these are kind of continuous search spaces, right? So, for example, we want our architecture to behave more like the simulation, right? The simulation is evolving over time. The simulation changes. So we have to come to terms with how do we actually create an architecture that changes? Some of it may be physical, meaning like our architecture physically changes. But I think much more of it has to be conditioned with the concept of environment. So in some of the projects, we've talked about multimateriality. We should design our version of what multimateriality is. So for example, multimateriality doesn't have to be, in a traditional sense, just printing with different materials and having a fixed architecture, but with different degrees of rigidity or plasticity. I think it could have all of those attributes, but it could also have other attributes. Our architecture could be a temporary scaffold for, let's call it, natural processes to take over. The same way that people, for example, when they have plastic surgery or reconstructive surgery, may be, implanted with a scaffold to give form to bacteria to grow or cells to grow or culture to give shape. But over time, the scaffolding disappears, breaks down, and allows something else to regenerate. So I think we should think about the concept of actually how we create space. Many of the things that we are talking about have no form. So, for example, if we talk about air, no form, water, no form, earth, in some sense, no form. All of these things are loose, particulate. It's like this Bruce Lee concept that water takes the form of whatever its container is. He has it as a kind of philosophy, right? You can Google this YouTube video where he says, be like water, means morph into your context. He takes it as a philosophy, which I think is kind of interesting. But of course, he's a movie star and all of those things, or was a movie star and very poetic as a karate master.
Nice reference, yeah. Bruce Lee.
I'm saying that because in some ways, like it's important to also understand that we're working in a very particular moment in time, right? And I want you guys to be as open and take the project as personal as you can, meaning as a group of individuals working together collectively. This is not about making generic architecture. This is about bringing your experiences together to try to create multiple readings of how a system can really be explored. It's very important that you understand that the team is really the source, and that includes your tutors. And that's why, me, Apo, and Mustafa are a team, Alex as well. And we need to operate in a way where we bring what we can to the table so that we can really think about things from different perspectives. It's not really about selecting one. This studio doesn't work like that. That's why the studio is not very linear. That's why Apo will say that sometimes we may not always know if the experiment was useful or not. But I would make the argument when you do it, you understand much more. You try something, you see, even if you don't know how you're going to use it, if it's interesting, it starts to play in your mind. And you start collecting these things, and like I said, the story emerges. We don't have to force that, but I do think we need to force the way that we try to do these things. The first thing that you're going to design as a system probably won't be very good. But the conversation around it, because you've taken some decisions, will be great. Because it'll force us to speak about something together as a common ground and say, well, how could we do this? What's the architecture? Is it the thing we literally put in space, or is it the atmosphere now that's defined by that? We have certain concepts, for example, like for the fire team, we talk about illumination. Illumination, what's the boundary of illumination? Is it just a perceptual thing, or does it have other implications? When we talk about gradated space, or when we talk about these other kinds of concepts, I think they're super fascinating, but they define space in a radically different way. We talk about heat. Heat doesn't, it may have a point origin, but the whole concept of dissipation is a radically different concept of space making. So how much of that can we almost take literally and try to think about and try to say, well, this can be architecture. You should also understand why David Green sometimes really wants to join our conversations, because we fundamentally question concepts like the machine, concepts about what architecture can be. It's not a response to a program that has a very linear trajectory. It's asking about possibilities. And you guys have to take also the position that architecture at the moment has to really start to change its, let's say architects have to change their concepts of what architecture can be. And there are many, many scenarios that challenge this idea of just program or building typology. You have to really understand that. So it's easy, and I promise you, I don't try to trivialize other projects, but if I said that we were designing a tower and we had to design a structure and a skin, there's no question about what you're doing. I would say, though, I would inherently question everything about, well, actually, what's the tower typology today? For example, is that just talking about verticality? Well, we can talk about verticality, but we can't assume that it's just about floor plates, a structure, and a facade. Because if we do that, we're not really inquiring possibilities. We are accepting certain problems as well. Do you understand what I mean? So we're starting from zero because we want to be able to question actually the things that we've inherited. They're not to say that they're wrong, but they're not fundamentally changing things as they are. And I want you guys to feel much more responsible about seeing your architecture having the possibilities for change. Now, when I say stuff like this, or when we've done this sometimes in the past in the studio, some people feel very burdened by some of the problems that we look at. And I think it's a very positive thing that they do feel that responsibility. But that's not how we innovate. We have to be very strategic. We have to also have confidence in pushing prototypically the boundaries of what we're working on, and allowing those opportunities and our creative response to those opportunities to come back and to think about how that can be new concepts of architecture, to be really radical and progressive about what we're talking about. If we have a flying turbine harvesting architecture, like we're talking about with the air team, it is amazingly powerful. If we could really do that in a serious piece of design research with the simulations that are responding to the environment, we're talking about a new ecosystem, not only for electricity, but thinking about how our architecture and our electrical grid can be mobile or can be set up in remote places. It has amazing potential. Just take the moment to think about it. If I could do this, what could happen? What could be liberated for architecture? What kind of problems can I address that other people cannot address with the way that they approach architecture? So our concept of participation in the studio also is not participation that, let's say, Sajay is speaking about. Participation in Sajay's studio is about choice, like personal choice, economic choice. Participation in our studio is much more conditioned on context. Context is as much social as it is environmental. It's as much cultural, and that's where I think the importance also of yourselves to come together as a team is important. Not just individual teams, but the studio as a team, to share perspectives. And I think that that's something that, is also something that I think our studio needs to find more dynamic ways of making that manifest. I think when you guys are presenting, I think the subject matter, I think, is quite interesting. But I want the architecture to be much, much more engaging, because it fundamentally challenges the way that we think that architecture can exist. And some people may say this is not architecture. You have to be okay with that. It may not fulfill the definition of what people may think architecture is. It may not look like architecture, but if it functions in terms of generating space, if it's responding to different ways of thinking about shelter, different ways of thinking about infrastructure, if we can really make some aspects legible, I think it's an amazing contribution. The best of the studio has radicalized many, many concepts. If I have to say self-critically, the worst of the studio is when we just somehow fall into like, okay, we're going to take this geometry. It's a pentagon. We've had 20 projects that are pentagonal. It's not an issue if we choose a pentagon or a sphere. That's not important. The important part is how we think about how geometry versus system, how materiality versus context, how those things have a synergy together. You understand what I mean? If you don't question that and you see it as a formula, and if I have to be honest with you, we really do have strong methodology. You will see internally that sometimes we really don't agree, like Mustafa and me sometimes don't always agree, that's because also we're responding with different emphasis on the history of the studio. We want to push. That may not mean the same thing for both of us. I also think that that's a benefit. It's like you guys working together. You may not always agree, but you know that the project is bigger than yourself, right? So, you know, I say it's my studio. I only say that as a kind of joke. It's our studio. And the definition of that every year has to come with people really wanting to explore as much as possible. Now I'm pushing Apo a little bit because when Apo is at his best, he works with you guys in a way that tries to make things. Making things doesn't always mean just doing physical stuff. Making things means how to try to work on certain problems where some tangible knowledge becomes tacit, and then that influences also digitally how you work, so that the digital and the analog world is seamless. We don't really care about file formats and what printing is. Like, we know how to do that stuff. We know high resolution formalism as good as anybody. The point here is sometimes to move beyond the concept of form and to think of it as formation. The difference is thinking about form in time. So let's start with one of the first teams so that we can become very specific about it. But I think with the midterm, I really want to start to hear a slightly different presentation from you guys. Making certain statements about what formation is, how your architecture is time dependent, and how your architecture creates space. And even a lot of the material that you've generated up till now, when you speak about it in this way, new things happen. New approach to thinking about it, new conversation. Who wants to go first?
Oh, maybe we can be the first one. Air team.
Please, Air team, go for it. I think I need to give you. Can you share your screen?
Yeah.
Cool.
Yes.
Does anybody have any questions before we go to team by team? Or any concerns? Should I take that as a no? Okay, guys, are you trying to say that me and Apo were totally clear? Well, that's awesome. Thank you so much. Let's talk about it in more specifics. I'm asking just so that you guys understand a little bit what we're talking about. You know, we need to force what it is that we're looking at for midterm, just to say, like, actually know that space. Those particles flying around the body, that's our architecture. Even if it's not the full scope of what it is, it starts to speak to the possibilities of something. Then we ask, is it flying? Is it self-propelled? If it's passive to the environment? You understand how those questions naturally start to happen as soon as we start to look at some of the simulations more explicitly. Okay, let's go with the air team, and we'll let you guys present. I say super silent. Apo can chat as much as he wants.
Okay, so we'll begin. We are the air team, and today we are going to describe which problems we hope to solve with the system we have been working on, and which scenario we are going to deal with. So we are divided our presentation into three parts. So firstly, it's about the scenario research, and then is the design of the system, and at last we will discuss our unit design. So firstly, we know that the cities means better resource and more opportunities for peoples, as people always tend to move to areas with more economic activity. Many people go to cities to study and employment, which brings about the rapid growth of the urban population. We know that the high density cities have the advantage of convenience and vitality, but at the same time, they also face the challenge of traffic congestion, resource shortage, loss of the natural green space, and environmental pollution. We know that the urban problem is not an architectural problem, but a social problem. It is influenced by a combination of economic, politic, and culture. Now, in the developing countries, there is little we can do to deal with the population pressures in cities through the conventional strategies. Therefore, we hope to solve three problems to some extent by means of mobile and flying architecture. There are lack of green space, the urban congestion, and air pollution. We take the Shenzhen for example because the city I'm living in. Shenzhen has created a rapid growth in economy over the past 3 decades. The size of the city is also expanding rapidly. It also makes cities crowded and push up their housing price. This has forced the later generations to sacrifice their right to rest and trade their long commute for the chance to live in the city. According to the 2018 surveys, the average daily commute time for workers in Shenzhen Science and Technology Parks is nearly 100 minutes. This means that many ordinary workers have to wait an hour or two before going home after a long day's work. People are not without complaint about such a hard life, but because of the uneven development of the region, they cannot escape from the city. But if we can provide them with temporary, flexible, and comfortable accommodation in the air, life will no longer be the same for many of the urban poor. We try to build a temporary living system over a density building in a city like the CBD. We hope to open up a new mode of living and commuting so that some people can live in the air to relieve the pressure of urban operation. The initial function of the system is to provide temporary resting space for low-income people with long commute. We can image such a flexible and individual-based and residential space, which consists of small units that can be inflated and compressed and fly. Each unit is equal to a usable space. Different units can be combined into more functional spaces, such as the residential community, a social platform, or a store. The system energy mode is a mechanism that gains more energy than it consumes, and energy that keeps it running comes from the wind and solar power. They are all clean energy, and it doesn't require cities to charge for it. Image an energy harvesting unit, a system like the BAT we had talked about, whose skin can be inflated and it can rise high into the air to generate wind power, and the residential unit can fly in the air and connect to the power unit to obtain the energy. A single power unit can charge a certain number of residential units. And at the same time, several residential units can be charged into different functional spaces according to the need, and their size is also flexible and variable. It has the inflatable walls and flexible structures for individual units, and several unit living and different living unit and power unit also would form a basic community in the air, and they're flying and working together. This ensures the energy ensure the energy of the each residential unit. We think that after a period of use, the congestion, lack of the green space, and the air pollution in the city will be gradually solved. As for the city, after some people live in the sky, we will be fewer cars, so the traffic congestion will be reduced, and with the comes the and also there will be the reduction in the need of the road, so the ground can be left more open to public space and natural green space, so the air pollution will be reduced. After the popularity of the flying city, people will gradually improve the functions of the living in the air so that the city becomes more three-dimensional.
And what this page want to express is the relationship between the development of the system and the function of the city. In the initial state, the system is responsible for solving the housing problem for young people. With a continuous interaction between the system and the urban functions, the city can release more areas to the natural environment, and the system also gradually increases its functional structure, making the floating city more perfect. In this scenario, we don't want to imagine the future city based on the cybernetics to exist only in the concept or imagination. Instead, we hope to relate this research method and the possible result to the actual situation, promote the development of the new cities in the time dimension, and increase the possibility of human activities. Next, please. And here is another scenario, the disaster scenario we want to discuss. Natural disaster refers to the natural phenomenon that brings harm to human existence. Natural variation on the Earth, including the natural variation induced by human activities, occurs all the time when such variation brings harm to human society. It constitutes natural disaster and brings different degrees of damage to human production and life. Therefore, natural disaster is a manifestation of the contradiction between man and nature, and is one of the most severe challenges faced by human beings in the past, now, and in the future. With the increase of the range of human activity, the impact on nature is also larger and larger. All kinds of disasters are increasingly frequent. Society needs to make more emergency plans and preparation to mitigate the impact of disasters. Next, please. Flood refers to the phenomenon of flooding in low-lying areas due to heavy rain. Its influence is comprehensive. That is, it will endanger the safety of human life and property, but also affect the growth of crops, bring huge damage to urban buildings and the facilities, will bring epidemic, secondary disaster, and so on. Next, please. So far, floods are still the biggest disaster affecting human beings. Flood disaster affects a wide range and has obvious seasonal frequency. At the same time, flood disasters often occur suddenly, which makes it difficult to evacuate people from the affected areas and requires more flexibility in disaster relief strategies. Next, please. Imagine such a flexible individual-based residential system, which consists of small units that can expand, compress, and fly. Each unit is equivalent to a use space, and different units can be combined to solve into more functional spaces, such as residential communities, social platform, or stores. Next, please. The system is a floating airborne energy harvesting system and a post-disaster shelter system consisting of a floating public service unit and a separable energy harvesting unit. On weekdays, the system can be added to a different location according to the needs of the community to provide small theaters, gyms, supermarkets, and other services for the community, and use the separate units to capture electricity and clean water energy at high altitude. In the event of disaster, residents are provided with temporary air shelter to help them through the dangerous period smoothly. Next, please.
Yeah, the second part is the scenario design of the system. Yeah, next, please. In our system, air provides a source of energy and expands people's living space. The design includes two types of basic units: the larger energy harvesting units containing wind turbines and the smaller residential unit. The energy harvest, the power unit uses high altitude wind energy to generate electricity and serves as an energy center. The residential units float above the city, providing convenient temporary shelters for people, maybe busy workers or after the disaster for city people. And the energy harvesting unit is surrounded by the residential unit, and the residential unit obtains the energy required for movement and people's life through the connected device. Next, please. And when the environment changes, for example, when the wind in the suburbs is stronger than that in the city, the energy harvesting unit will move to a place that is more suitable for obtaining wind energy, for harvest of wind energy. The residential unit will use the stored energy to maintain a floating state until the power unit returns with full power. Next, please. Due to the technical limitation, in order to increase the conversion rate of wind energy, we may need to site the energy harvesting unit to a form that is connected to the ground during the charging process to reduce the energy consumption of the power unit. Next, please. In addition, the entire system will adjust its location according to people's needs. When more residential units are needed somewhere in the city, the power unit will migrate with it and attach the residential units and gather it, and they will together. It can be connected and combined to form a complex activity space in the atmosphere. Next, please. Finally, the entire system will be, as shown in this diagram, the energy harvest unit and the residential unit will not be a constrained correspondence but a dynamic state. There are energy harvesting units that are moving and harvest energy and transmitting electrical energy for residential unit over the city at all times, forming a complete system. Next, please.
Then we have some simple ideas about the design of air modules. In general, our system consists of two kinds of modules, which are small modules for living and public activities, and large modules in charge of the energy acquisition and control the system. The most important thing of designing the small module is good connectivity in all directions so that information, water, and electricity can be easily transferred between these small units, and they can easily gather together to form a larger space for public activities if needed. So we think the prototype transformed from a regular octahedron is very useful because it can be connected right above and right beside by the square sides, but can also be connected by the hexagon sides. Due to the time limitation, we just tried the orthogonal connections method this week, and we also plan to try another way in the next step. Next page, please. This model is very simple, but sorry, last page. Next page. Sorry. This model is very simple, but in the design of small module, we focus on 3 points. First is affordability and scalability. For example, the 4 hexagonal panels on the top can be used as propellers to control the flight directions when they opened up. And secondly, there are paths for conveying water, electricity, and other energy sources in all directions. Thirdly, there should be sufficient equipment storage space and activity space also. Next page, please. Okay. Last page, please. Okay. So, okay, this page shows the way they connected when they fly. Modules on the same floor can form plans for more activities. This page shows the design of large modules, which is responsible for energy harvesting and controlling the whole system. 3 layers of rings act like a gyroscope, allowing the system to rotate correspondingly to the direction of wind. And each ring has several chargers, allowing the small modules to get energy and water from them. And the larger energy harvesting modules should also be connected to the ground by ropes or other things, or it will fly away. Next page, please. Yeah, that's all. Thank you.
Okay, guys. I mean, I think this is a good presentation because I think that there are certain things that you guys are expressing which I think are useful and provocative as an idea. But I think that we should kind of clarify where the strengths of the argument are and where the weaknesses are, and try to be a little bit sharper. So, for example, you guys started with this idea of looking at Shenzhen and looking at the commute times and speaking to concept of the worker as in a way of thinking about sort of generating, affordable, let's call it almost like social housing in this kind of floating air-based infrastructure. If I take that as a scenario, how many workers commute to Shenzhen? Millions?
Maybe.
Okay. Why is that important, do you think?
Because I think they sacrifice their rest time.
Focus on the design now, Gaucho. I understand why we would do this. I'm talking now about numbers. If we say 1 million, if I look at your diagram, let's say you have 1 sphere per person. What does 1 million spheres look like? How does 1 million spheres organize? How much surface area powers one sphere. And that's how we start to really understand that this is not just about sketching a vision. This is about taking those real world problems now seriously. You understand what I mean?
Yes.
And
So it looks impossible for one person, one sphere, because there are too many.
you cannot have that approach. Gauja, you have to be more radical. You're telling me you want to put people flying in the sky. I want to believe you guys. But now you're telling me it's impossible to have one sphere per person? It's pointless to do this. So release your mind and focus.
No. I think there are some way to deal with this problem.
Yes, Gauja. I think that there is some way as well. I'm very much convinced, but I want you to not tell me not possible, because you haven't explored it. And a sphere, we don't know if that space, like literally we're making pods like you guys are presenting. A sphere is just one unit of space that could be for one person. So actually, interpretation of space making needs to be understood with volume that is discrete so that it can allow itself to recombine. And this is how we start to shape the problem. We start to look at the simulations. Now, commuting time by itself is not enough of an argument to make a city, floating city for, let's say, 10 million people. By itself, it's not enough. So when you said the other part of the argument was about green space. Green space now is like very generic stuff. What does that mean? Is that like park? Is that like this, that? Not sure. But you said something, you guys said something that I thought was very important. You said to utilize and capture the environment, which is high energy for electricity and water, right? And I think that that's a very interesting way to conceptualize the project. But it would be very interesting if we don't take generic way of thinking about green space like park, but we think about it as resource for farming, for example. If you take urban context as a problem, means that we have to ship all kinds of vegetables, all these things from rural area to city area. We can start thinking about green space as actually farm, landscape, park, hybrid. And this would be something very different. This would be like these concept of the floating garden or the hanging garden. It would have a very different idea. So when you guys show, like in slide 6, for example, you have BAT unit and then 4 pods that are just kind of floating there. Let's put it this way. I think this is a really good, horrible image. Really good, because it explains technology of BAT and floating pods having some relationship to it. But very bad if I look at it seriously, right? BAT system is a tethered system. It's the one that has to be grounded and is moving. Pods have to be moving with it. So is the question that the pods are attached to the BAT in this context? Is it only about 2 different modules, like you're saying? I don't think that the number 2 matters, and I wouldn't separate. Here is BAT source, and here is module. Think of it how a particle swarm system would be moving together. This is closer to what a high population movement would be like, no? Do you understand what I mean? Like when you see the flying birds flocking together, actually, they are choreographed swarm. Their choreography is also about movement. They move together. They make a super organism. Still, everything individual can break apart, can come back together, but they work together, not separate. It's a collective organization. It's a collective system. Why is that important in this context? If these things have a very passive relationship between each other, you imagine you have balloons flying together, they will start tangling together and fall. They will cause conflict with each other, turbulence with each other. They will not work together to create something bigger. Now, that's just for flying something, but that's also important for it to be a new concept of city, right? We want to have social interaction. We know communication is very important. We know that there is no such concept as the ground, so we have to generate ground. So how do these things aggregate together? How can I occupy the roof of these things maybe as a new ground? We need to think about things like this as well, right? So I think these are great because they help us to explain, to work through them. They're like sketches. You understand what I mean? So for example, go back to your slideshow. Scroll down. For example, slide 12 has an implication that the spheres together can start to be making metaballs. So we have different sizes of spaces. When I look at this image, right? Do you know what metaball is?
Yes.
Okay. So it's fusion of spheres, right? Now, if I look at that and I say, well, that could be a possibility, that has also some implications which are very different than just aggregate of one particular geometry, right? Because they fuse together to be something different. So even as a concept, we can start to look at the difference between designing a system that has a certain volumetric description, like for example, sphere can be different sizes, but we have to talk about the fact that we can't occupy a sphere in a normal way. Like for example, Apo's project, which I think you guys have seen at some point, right? He never had to put floor plates in it because we put it in space, no gravity. So you swim through the metaball. In your concept, for example, though, if I take this image literally, there's also something kind of interesting. For example, when you look at air as an environment, you will see that there are also a lot of flying structures that are very vertical, like vertical stacking. And they float in this kind of organization because we have very different kinds of airflows at the different strata of atmosphere. So when we say organization, your organization in terms of how these particles come together would be very different at the different strata of atmosphere. As it goes higher, the air is less turbulent. When it's lower, the turbulence is much greater. So where does your architecture float? Even if we said something like floating city, its organization will be different because air now is the new ground for us. You understand what I mean?
New ground, for example. Yes.
So I want to start to see some of those things, like the diagrams from 15, 17, these things, they're kind of sketches. They're not really diagrams, right? This is kind of expressing some intention. So I want to start seeing the simulations. How do the particles look like? So for example, here, click on that diagram, like 17. For example, you tell me architecture is left, right? But maybe architecture is right, where I just see these things as little islands. Do you know what I mean? The way that you've drawn it, for example, 1 second. take a screenshot. Ay. I can't draw directly on your project, so I have to do it.
Does your annotate tool doesn't work, no?
No. Does yours?
Yeah, because I asked from the school to do it. It's a feature they need to unlock if you have that problem.
Can you draw on this?
No, because you made the meeting, but for the next time, I think if you ask them, you will get it. I had the same in the beginning, and then I said, we are in the 21st century, give me the annotate. So they gave it. You just need to do that.
Okay. Good for me to know.
Yeah, just for the future, it's good to know.
Yeah. Okay, give me 1 second to just share my screen, okay? Can you see
I stop sharing.
Can you see mine or no?
Yeah.
Okay, these are going to be the worst sketches on the planet, so please excuse, but hopefully they'll be. Here, for example, you have these things as individual units, right?
Yeah.
And so they look literally like balloons. I think if we're talking about a million, let's just start as a million. We're talking about things that are really like this, right?
I mean, yes.
Sure. So let's say that's Shenzhen. We would have islands almost like clouds. And then almost like airports, we would have things moving from one to another. Or one concept could be we would make a whole carpet over the whole city. And like rain, these units are migrating up and down, right?
Yeah.
Do you understand what I mean? This would be our architecture. Our architecture is not just saying we're going to make some floating buildings. Our architecture is looking at this relationship between the city that you're saying it's supposed to serve, and by instead of just focusing on the ground, we are generating a 3D volume of space. Contemporary city in Shenzhen is just ground interface, okay? Means everything happens here. But if the true concept of the urban is meaningful, means that actually we have the possibility of doing things here. And we have a lot more space up here. But we also have other challenges too, right? We have airplanes. Our architecture and this flying architecture has to have now a new ecology. We should know where the flight patterns are. Our system should never interfere with that. Has to be an intelligent system. So the idea of mobility is also quite clear, right? When we say the BATs need to be tethered somewhere, where do they tether? To the ground? No. It would not really work, would it? It would interfere with the buildings. So maybe one concept is to say, let me change the color. The new ground that our architecture is looking at is not to bring people down to the ground, but to interface with the existing city, maybe from the rooftop. For example, I'm living here. That's Theo's space. Theo is working in this building. So my pod has to commute to that. You know what I'm saying?
Yeah.
So more like an airport traffic control system. So even the concept of control should be something like this. how do I interface these moving kind of strategies computationally? Do you understand what I mean?
Yeah.
Kauja, you're looking perplexed. What's going on?
I'm confused. Yeah.
What are you confused?
I think it's more like the science fiction, not based on the real technology.
It's not based on real technology. Kauja,
Yes.
I didn't know you were so conservative, boy. What do you mean it's not based on real technology?
Because it looked like you move a huge city to the sky, so it will become many people, so many people, like a million people, and also they need to eat. They need some many functions, and also the cloud will be very heavy, and also I'm thinking about the energy, like people live in the city, they need to consume a lot of energies to maintain their life. So I don't know how to make so many energies to the sky city.
So let me ask you a question, Gauji. When you guys tell me that you have four pods that can get energy from one BAT system, that's real? Yes?
Yes.
How is it real? You have a simple equation that says one BAT can serve so much area, right? Generate so much energy.
Yes.
Correct? Okay.
Yes.
You know what's really easy to do? Tell me how much volume you need for 1 million people. If you can do it for 4, you can do it for 1 million.
But I think the function is different.
I'm not talking
like,
about function. You said about energy. Do that. Now you're saying Shenzhen. Shenzhen is a very defined boundary. So if I use that as a surface area, then the question is, how do I distribute 1 million over the map of Shenzhen? So if I have a map of Shenzhen, right? Sorry if I don't know what Shenzhen looks like.
Yeah.
Okay. Are they all consolidated here? Or is it a system that's distributed, obviously, throughout Shenzhen, right?
Yes. Oh, I understand.
Gauja, I'm very realistic boy. I'm just trying to get you guys to start to think about how you work on these kind of problems. If you don't take it seriously, then yes, it's science fiction. But if you use science, then you make calculations, you know how much surface area, you know how much energy. You don't just design a pod because you think that's what a floating city should look like. You start to understand the problems of generating a floating city, and you start to work on them. And you start to use simulation to challenge the way that we think about organization. But this is a diagram, because if you say this is a floating city, then I have from here up floating city. Well, actually, that's just floating infrastructure. Floating city is actually just new city. The existing architecture is important. We're augmenting it with what you're doing, which is a tethered architecture that extends the physical building into the atmosphere. So the way that you see it helps you understand what actually is the real problem. That's what I'm trying to get across to you. So when you draw one BAT with a couple of tentacles and a couple of pods like this, for me, that's science fiction. Because that doesn't give me any organization between the pods. It just makes me like David Green in a plastic bag, floating, like I'm in a weather balloon. That's not living. That's not generating energy. It's just hanging off of a balloon. But if you say to me, this is how all of this is organizing itself into this floating architecture, you can tell me how many of these pods are organized inside, and you don't separate BAT from your living pod, you see it as something fused together, I think becomes super interesting. And then control system is more like an airport, things coming and going. You understand?
Yes.
Is it science fiction or is this the project?
The project.
That's it. Now, question about disaster, I think should be a question about the ground. I think in your case, for example, when you talk about disaster, of course, your architecture should speak about the fact that it doesn't have the same problems of urban city because the architecture can lift off the ground. So I wouldn't make it about disaster complexity like last year's studio, but I would suggest that it is like almost like an airbag in a car. If some event happens, the architecture has the ability to lift off the ground, right?
Yes.
But I would suggest the statement that you said about high energy and electricity and water becomes some of the conditions which happens here. For example, I can imagine aeroponic system. Let's use ugly green to explain garden, my greenwashing. You can have an aeroponic system that's growing food. You know, you can do a simple kind of equation to understand how much production through aeroponics, how much can you grow, how much can you cultivate, and how much water you would need for an aeroponic system, which is much less. And in Apo's year and the year after Apo and stuff like that, we had, I think it was the year after you, right, Apo? Ralph's year. We had a floating farm project, for example. We did some of that research just to make farm, just to grow some vegetables. You can't grow everything, but you can grow certain things. London imports like 90% of the food. That's not sustainable either, right? So these are very real problems, and maybe you need a radical solution. So it's not to design the project, but you could do a problem like this. So based on your presentation, this is where your simulations then are not just agents. Your simulations have to be much more controlled, right? Instead of floating in space, they should be organizing themselves as clusters. We can have a network diagram of particles that are emergent when we have a collective together. For example, here, if I zoom in and these are all pods that are linked together, there should be a network. What color do you like? Purple? That connects all of these things together. So I should be looking at a system that has an internal infrastructure, even if this is all like one cloud looking thing at a certain resolution. When I zoom in, all of those particles together are generating an interior nervous system that this thing behaves as something different. How do people move inside of that? And I could start to see, I think, different ways of thinking about it. Okay, those are housing. Well, then this green stuff are also growing areas, or whatever you're calling green spaces, right? So I start to see it like if I'm zooming in with a microscope, this cellular strategy. Does that make sense? Guys, everyone talk to me now. Apo included.
Yeah, well, I hope I'm not confusing you more now, but that would be my opinion on the project. I think it would be good to discuss all together, but I think there is something exaggerating a bit. I think there is a missed opportunity. I I think you're using, for me, it's a very interesting system. This inflatable turbines, I think they're amazing. You're using something that the strong points are actually getting lost within the context you're trying to put it. And I would agree with the sketch of Theo and how a kind of a flying city could work. But very easily, somebody could say, okay, well, let's get this diagram here. We have a very dense city. We can make it denser, right? We can make very, very tall buildings that they give to people, place to stay, food, everything. That's not going to resolve the problem that we are living these days, like very concentrated cities that they are inhumane. So using this kind of mobile energy systems, you get the opportunity to decentralize the way people live, and you decentralize also mobility, make independent mobility choices. For instance, you can, I think Theo said it earlier, the perception of green and farming and how you generate resources. You could bring energy to areas that actually will never have energy with a tethered system. Then you can take those products, you can move back to the city, or you can move back to other areas where they need products. So you decentralize the way you manage resources. And if we want to see, let's say, future and whether, let's say, we are going to ever need again concentrated city domains, because, let's say, financially everybody needs to be there. I think we are turning into a nomadic model anyways. We are turning to more remote working. Like every day we go to more remote, more, let's say, decentralized models. So how do you support these kind of models? How can you do, you have kind of energy independency, how you can have mobility independency, and how can you occupy more surface rather than less? The cities was developed as a dense fabric because of that. They were trying to resolve the problem of moving things around and energy. But your system actually can propose something completely different. So for me, it's a little bit contradictory to try to have a parasitic architecture on a city rather than use it to expand. And it is a little bit the opposite of Theos, but maybe there is a hybrid model in between the two. And I totally agree. If you start putting the numbers down and you say, let's get 1 million people in those bubbles, actually, you're going to reverse the city model. You're going to do everything about it. You're going to hit the wall somehow.
Well, let's put it this way, Apo. I don't think that my sketch is what they should do.
I'm not saying that. It's ideas. At the moment, any idea is good.
Your point of the fact of it being mobile is very important. I think the attention to the problem is what they have to somehow articulate. So, for example, in a post-disaster scenario, that's one conversation. The only thing that I would say is, important from my side, different from what you said, was just your use of the word parasitic. So, for example, I wouldn't see the sketch that I did as something parasitic. I would say it's augmenting problems that maybe are not so clear. For example, nobody sees the image of Shenzhen or the densification because of all the commute. And nobody sees where the food is coming from that needs to support a system like that. So if we focus of architecture as an infrastructure first, one scenario is that it could augment some of the problems of the existing city. Another scenario, prototypically, would be what you're suggesting, that it can generate a city that is decentralized without that dependency on fixed infrastructure. And what would make it prototypical, from my perspective, and I think you would share that, is that actually the system is not the same. The system is the same. The application is not the same, which means the population of the system would be different, and they would have a different relationship, for example, to the ground.
Yeah.
So I think both of them are two scenarios that can still work 100% by designing the system.
Yeah.
And
No, I completely agree on that. The system itself, it's the same, but I think the application, just on some of the concerns of whether it goes to sci-fi or it goes somewhere that doesn't make sense, I think it may be a different way to see it, and it may help you to deviate from that.
it's true. I think the thing that I want to be clear, at least in terms of how we work on the prototype, is that we don't fall in love with dealing with small scale. For example, we're going to deal with 100 units and feel that that's prototypical. And especially not when we talk about air, because, for example, higher population will create more stability. If we have a series of discrete balloons, let's say the balloon is 50 units or the balloon is 1 unit, if they are not thought about collectively as an organization, it will be highly turbulent. It would be a terrible place to live in a weather balloon. So high population also creates the possibility of creating more flight stability. And those are kinds of things that we're not going to be able to answer everything together, but we know that surface area matters. You know, that organization of discrete elements by themselves will have a very different control system than a tethering system that is collective, that has multiple points on the ground. So instead of, lasso-like strategy that could become very turbulent, it would have much more stable strategy because there are multiple points. There are going to be very different problems. I think the issue, is that it doesn't change radically how you design the system. It changes radically how you apply the system. If we keep these extremes together, I think it sets up a system that has the possibility to be applied to either of them and would challenge the way that we would think about organization in terms of scaling up or scaling down or partitioning the system, right? So instead of the mega cloud floating city literally, it may be thousands of little islands like an archipelago in the sky or something, right? We would be taking those decisions based on also how they're relating to each other. So the opportunity to connect to the existing city is that we're augmenting that city. We're not trying to make a completely, almost new vernacular in the sky. It's not like a village that has to somehow self-sustain itself in more traditional ways completely. So I think the thing that's very important is to treat it infrastructurally first, to really start to quantify volume with electricity being generated, and I would say food production as well. I think that that's two elements that I think is a good response to survival, right? So in your case, minimal water harvesting is really about food production. It could look at things like aeroponics. And if we have a decentralized electrical grid like that by itself, if we can make an argument for how many of these things would happen to power a small part of the city, I think that's an amazing prototype. Because like you guys said, the weather vanes and, these weather vanes, like the wind turbine things are powerful, but they're fixed. So they're not really optimized and they don't change. So having the capacity for it to be mobile doesn't mean that it has to be remote. It means that it has to be responsive to the environment. So it can change its orientation to capture wind. It can move with the kind of wind cycles. It doesn't have to have a one-on-one correlation with what you're calling living. And if thinking about a floating city by having people on it as a distraction, let's kill that right now and just treat it as an infrastructure. I don't think it's a distraction personally, but we can take the position that it's infrastructure first instead of like it making it more like an elevator strategy that has to negotiate people up and down. Do you understand what I mean? So most important problems is how much food production can be made, how many units are flying, how do we develop flight control for those units to generate things. I think making these kind of like sketches like 6, or, if I look at 7, for example, this is where I think the argument fails. Go to 7. You're showing me year 1 and you're showing me 5 years later, and the only difference is that we have like 5 more balloons. I would almost say year 5, all I see is pink. If this is a top view of the city, and this is about growth, what do we mean in terms of growth and density? If it's production of food, it would mean how much of this floating farm would generate enough food production to sustain this particular part of the city, right? If it's about energy, it would be like, how much can we offset the electrical energy of this particular area? Does that make sense as a diagram? Guys, you need to respond now. Yes, no, Theo?
Should I say yes?
Yeah.
No, I want to hear it from them. Guys, are you excited, scared, worried? Everything above? It's okay, it's good.
In my opinion, first, the urban problem and the post-disaster problem, first we introduced is just 2 different scenarios, and we didn't decide which direction to take. But in the comment you have side, maybe we will going to build a very comprehensive and complex system, including the space, architecture, space, electricity, and food, energy, and transportation, or more. And maybe the transportation system is the one that we need to take the most computational design, right?
I think the transportation system by itself, like I mentioned, it's not enough for the scenario. That's why I'm saying, like, it gives you an idea of how many people are migrating, right? So the difference is that there's also a lot of energy exposed. People are traveling quite a lot. I'm not saying quality of life would be better to be in the city. So even the concept of mobility is, well, is your architecture mobile or are people mobile? At the end of the day, it's a shift in that emphasis. So I think the argument should be in terms of infrastructure, that it's a way of it's creating infrastructure that can either augment some of the problems of the existing city or create the foundations for creating new settlement or new city. Does that make sense? Because by itself, it cannot address everything. That's why we call it really elemental, kind of like survival architecture. But with electricity and basic food production, we can really have a very mobile concept of infrastructure, which I think is amazingly powerful, right? It could be used for many different things. So these comments are obviously for like all the teams in some respect, but I think like these are the kinds of ways of thinking that I think are important. and how to now take some of also the simulations and target it with certain problems that are emerging, like in the conversation. You know, if I'm looking at a flock of, you know, starlings, is that your architecture? Do you know what starlings are? I'm sure you've seen these videos. Apo really loves flying starlings.
Yeah, my favorite.
This is a portal to your future. And bring it. Come on! Introducing the all.
My brother was interviewing for a company, and they produce interactive mirrors, usually for fitness and for medical stuff. So now, I guess because my laptop has been open with some of the conversations, I get their advertisements every time I click on YouTube. So
Nice, isn't it? Huh?
yeah, good old YouTube. Let's keep trying. Is this your architecture? Excuse the music.
It's very cool.
It's very real, Gauja. Not the simulation, real. Now, if I just look at this for an example, right? Even seeing the birds flying off the ground, all of that stuff, it kind of gives you some example of some of the problems, right? Of having discrete elements that come together, create something more collective. And you understand this not from the body plan solely, but from the concept of choreography and mobility, right? You even see the formation becoming more surface or becoming more volume. And now let's say if we interpret this, if we said that the time frame it takes to make change, we could say this is happening over a day or this is happening over an hour. You know what I'm saying? When we interpret what we look at in this kind of world, is something different. So I want you to think a little bit more like even your background, Gauja, with the Northern Lights. Why could that not be your architecture? And then the question is not why for us to answer, the question is how.
Yes, I agree.
And we have kitten too. Okay, we end on the cat. Does this make sense to you guys?
Yes.
Good. Okay, can we get the next team?
I have some question. I think like our system can finally deal with the problem in different city with the same issue. But at first, should we take some specific region to start our design?
What I want you to do is just find a couple of ways to sample some numbers to give you, for example, you said the daily commute as an example. How many people daily commute to Shenzhen? That's one scenario. Or you can do the opposite scenario. How many people are living in a satellite city to Shenzhen that are commuting from a local town to the main city? So if you take one train station and you say in that region there are so many people, how would we make a decentralized city infrastructure for them in the more rural area? You understand what I mean? It's not really about sight, it's just to kind of pose the problem with a couple of numbers to explain the two different approaches, let's say, that we talked about in terms of application. Apo's concept more of decentralization, which, to be honest with you, I think is very powerful. But the application is different because it means like it's the beginning of a city. Because you create a food resource and some electricity, then there's a lot of other things in terms of what it means to live there. So I don't know which one you would take yet. The disaster complexity, the only thing that I'm mentioning about it is like the argument for a flying architecture should be that the ground always goes through radical change, and architecture should be able to respond to that without having, let's say, the problem of fixed infrastructure. So when I look at the problems of slide 9 and 10, I see it as the problem of an infrastructure and an architecture that has no capacity to deal with environmental change.
Yes.
We don't need to speak too much about making post-earthquake housing. It's more like design a city so that this destruction of architecture does not happen. Does this make sense?
Yes.
I have a question about the. Oh, sorry.
You can ask.
I have a problem about the formation of the the birds or something. Like in our system, the BAT system is more like connected to the ground or the roof. It's if it move, it's like move very slowly. So I think the formation only happens when the whole system remove from one place to another place. In this process, they can make a formation, but in most of the time, I think the system is like stay in one place. So I'm not sure if the
system in your case may want to stay in one place, but your environment is very variable, right?
Yeah.
And if you want to make a balloon stay in one place, it's almost impossible to keep it frozen in one place. It's always going to be moving, right? Always. Yeah. So in terms of formation, don't take the bird example too literally, but I just want to explain how each individual bird is moving together in choreography. Do you understand what I mean? The rule set of the flock is really about the relationship between the individuals.
Yeah.
It's not really about flying and doing this stuff. It's more about how they control the space between each other to move together so that there is no clashing. It's an intelligent response system. That's all I mean. So yes, I agree with you that it's a tethered system. It's not going to be moving literally like the birds. But I want the rule set of the choreography of how they move collectively together to be in reference to each other so that it's more of an intelligent infrastructure than just a series of balloons that are floating. So for your simulations, I would start first of all with a series of floating elements, show how they move together collectively like a swarm to respond. Your simulation should take the tethering point and look at different kinds of connections between the tethering balloons to create more stability in your simulation, right? So the balloons should have a relationship together, so they may have multiple tethering points. Instead of like each balloon having one tethering point, you start there, and then you try to find more intelligent ways that the tethering strategy can deal with more balloons. So how much control can we have of the larger organization with minimal control points in terms of tethering? These are some of the studies that I would be doing in the simulation to see the influence of a kind of elastic spring to the balloons and between the connections between balloons to organize themselves to minimize those tethering points.
Yeah.
Okay.
Okay.
Yeah.
I'm sure you're going to have hundreds of more questions, but it's just really to kind of focus on the thinking so that we can make some real push for midterm. So you present this project in the midterm, basically. Okay? Exciting stuff. Okay, last question. See you on.
I think I want to ask some data questions. We can extract some accurate data from some techniques, but for the most part, we can't be sure. So can some of our information come from our assumptions? Or
Yes, I think those assumptions should come from as much of the, you don't, like, for example, we're not just taking BAT technology as is. We're using BAT technology as a concept with a certain technicality that we know in terms of the amount of energy produced. But we are going to redesign this system.
okay.
So yes, you should take whatever existing knowledge is so that you know the size and the scale and how the BAT system works as a technology, but we will redesign how it's deployed. Okay?
Okay, thank you.
And don't be afraid of having a couple of different scenarios with very different numbers. So you can do a prototype with maybe 50 balloons and use that as a simulation, but also then do the simulation with 5,000 and then do a simulation with 500,000. Your concept of that same simulation with different population will be different. And that's what the studio is. Not just working on one scale. This is also the problem in Sajay's studio that I tell them all the time. You cannot just design, everybody just take a piece and plug it into something. It just looks like a collection of stuff. And if you deal with it for 40 or 50 apartments, fine. But if you have to do it for 5,000 or 5 million, it doesn't work this way. So that's why we need these kind of emergent properties to happen, so that when we change magnitude of scale, we have some principles that allows that change to be dealt with a different concept of control. Okay? Okay, guys, let's get the next team.
Thank you.
Thank you.
Who's next? Water? Earth?
We're here.
Heat?
We are ready, but we have a connection issue. I can try, but I'm afraid that the connection will... give me 1 second.
Yeah, no problem.
Or if anyone wants to go next until I solve the issue.
If you guys are solving something. Guys, can I get fire or earth?
Can maybe the next one?
Of course.
Fire. Okay. I will share my screen.
Please.
So last week we added some new thing like the behavior. So we have added a new study on phototaxis, and when facing the light source, many microorganisms will not only gather together, but also escape from the light source due to the excessive intensity of the light source. And meanwhile, after absorbing the energy of the light source, individual microorganisms will also attract the other companions as a new heat source. And then and next should be the experiments we take, and we choose the sample to do a separate experiment. And the first one should be towards the light, and next is the escape from the light when it's so strong, and next is to rotate to the light, and last one should be the rotate to the other unit. And we take the group experiments and find something different.
Can I ask one question?
Yes.
When I'm looking at these simulations, there are two things that become very apparent to me. One of them is that the spawn count is very low, right?
Yeah.
So if we're looking at 1 or we're looking at 3, I'm not sure that there's that big of a difference. But let's say, for example, if you ran the same simulation, fixed light source, but you deal with increments that are like, let's call it powers of 10. You go from 10 to 100. Start to see how those things are starting to influence. You go from, for example, rigid organization to random organization, see how they reorganize themselves. And then you do the moving light source and so forth. The only reason I'm saying that is the difference between a spawn count of 3 or 5 maybe is not that different, right?
Yeah, so I think the next step we take them into the 100 and merge the previous performance as actually like this.
Yes.
And next in the this experiment, it was found that changing the search radius between individuals would not have a substantial impact on the path itself, and but would change the connection between individuals. And at the same time, the distance between individuals can be controlled to control the path of individuals, whether to move towards or away from.
Yeah, this slide is useful, but I would also make one comment about it if you go back 1 second. So, for example, at the moment, the concept of phototaxis here is the control with a moving kind of vector force that is moving towards the light, right? And for example, that has certain implications, like, for example, moths to a light source, this kind of example. That's a very different example, let's say, from the sunflower, which is really dealing with fixed rotation. So I think even in the ways that you guys are experimenting with this, I think, try to set up different concepts of what movement behaviors are part of the concept, because I like the fact that you're starting to introduce a network of behavior, even if it's invisible, with the red lines, which are like springs between the particles. But those can be motivated for very different reasons, right? For example, if they really are like flying system or something like that, that's space to maintain avoiding collision kind of stuff. But if it's a fixed infrastructure like a sunflower, it's about choreographed rotations, right? The field is working in a very different way when it's a field-based strategy versus an agent-based strategy. So just in terms of trying to explore different concepts of the relationship between agents, I think is important.
Yeah.
Keep going.
Okay, and the following characteristic is that when the microorganism gets close to the light source, it adjusts its inclination towards the light source according to the heat. And this is a simulation of constantly adjusting the angle in the process of getting close to the light source in the crowd, so as to minimize the contact area with the direct light source when getting closer to the light source.
I think the question with some of these simulations are like, if we let the simulation completely go to rest, what would be the last organization? For example, all of them are somehow moving within the range of the circle, right? And the point light. Yeah. But for example, if we just allowed this thing to continue to run and to move into a self-organizational strategy, what would be the pattern of those cells now? Would they reorganize themselves into much more geometric relationships because there's a center and a radius that's around themselves, and they have a very particular body plan? Would it look more like a phylotactical spiral in terms of their movement behaviors, organizing a certain formation? These are potentially some things that you can introduce further to start to look at how the organizations that are migrating and reorienting could have implications of spatial packing, for example.
Okay.
But the diagrams are clear.
Okay. And next, the following is the research on campfire. A campfire is a form of gathering under appropriate temperature, and people will gather, but too high temperature will lead to escape, while too low temperature will not produce the gathering behavior. So below are simulations of group behavior in the different scenarios. So the first one should be the high temperature. It can escape from the heat, and next should be the gather together to the heat source, and the third one should be the random one.
I think all of these are okay, but I think there's something about the strategy. If you could go back to the previous one. Yeah. There's something about the diagrammatic setup that doesn't give me more information, possibly. For example, we know that the light source is a point relationship, and we know that from the previous diagram, there is a threshold circle that's a boundary around it, right? And in your system, for example, the possibility will be for multiple, let's call it light sources or heat sources. So I think already you can start to use a diagrammatic process that has always the point and circle relationship, so that we have something that's not just centric, but that it's polycentric, that we can have multiple centers. Because in your argumentation, I think the light source or the point source or the heat source is an attractor point. But our architecture, in the context of how we work, it will always have a polycentric kind of model. So it would be useful to introduce the point and the boundary of affect as a strategy notationally, because right now I don't see that because everything is zoomed in, but I see a movement behavior that is always just migrating from, let's say, top left to bottom, top right to bottom left, for example, right? And I'm not really clear about why that's happening, because it's zoomed in a way that doesn't allow me to think about things happening in multiple directions. But the circle, in some sense, doesn't have orientation. So when we do random kind of migrating to a center, if we have that point and the threshold line around it, I think it becomes clearer as a diagrammatic technique then that we can change the population and introduce multiple point attractor conditions to it. And we can move through different scales and populations and speak about polycentric strategies. Okay, you can go to the next one.
So the next study is about the behavior of people in fire, the instinctive reaction of people in extreme circumstances. And first, we'll choose the familiar path to flee, and second is on high to the behavior of the direction of the earth. Then the conformity will follow the direction of the most people and choose barrier-free path, choose the easy way, and the one person in the fire, and to respond quickly. But when many people together in the fire, they will stay again after a period of time to flee.
Yeah, I have to say that these diagrams are not so clear, because in some sense they make human behavior like very mechanical. But we know that social scenarios make that, this is almost how like Patrick will describe a crowd or how someone is supposed to behave versus how humans behave. I think it's important to, you're using an indexical strategy. So for example, also the cube as a human, I'm not sure what the attraction, what the communication logic of that is. So for example, when you're trying to explain human behavior, you don't have a scenario, like a social scenario, or a certain population that would make that legible, right? So right now, what are we exactly trying to communicate with this? You're saying, for example, humans choose the familiar path. Maybe, depends on the context. For example, if I walk out of my house and there's a fresh snow that has fallen and someone has walked before me in a path, I know that that path, let's call it, was a safe path to walk. If I had some qualification about what is a legible path, or if I don't have all the signals of where, let's say, the sidewalk is, I can look at the notation system of the footprints of someone else to know that that was a migratory path that was, for example, successful. So in a strange way, that visual organization is a byproduct of visualizing path. Here, for example, it's very difficult for me to understand the context of what path means, because I don't have a concept of obstacle or maze or something that basically is trying to understand how path is something conceptualized as a problem, right? Here it's just basically saying that people are habitual, and we know that, but that's not really generating something in terms of an algorithmic response that gives us some concept of behavior in the way that you guys are going to be speaking about it, right? So you're talking about this not as a generic crowd study or animatronic kind of way of thinking about humanoid, bipedal movement. You're talking about this really about ritual and choreography. So for example, human behavior around a fire can be dance, which means that it would have a very different movement behavior, which is not habitual, it's choreographed. So I would think about human behavior as a choreography, because I think through that choreography, we would understand a little bit about ritual. If we see a human pattern that is emerging with synchronized choreographed movements, we know that that's potentially much more ritual-led than if we see, for example, random movements that are going from A to B. That can be more everyday scenario, right? So if we track pattern of movement as a way to describe human behavior, I think I would try to use a couple of examples around the concept of fire, of how that can be looked at in different ways, right?
Yeah.
You could think about that also in terms of, you'd mentioned it in terms of fire disaster, but that is a concept of scale as well, right? Of the fire. So that means intensity. And you can visualize that mapping of intensity in some way. And that would show the behavior of things moving away from the source instead of moving to the source or moving around the source, right? Does that make sense?
Yeah, but I think the human behavior should be the regular behavior, because I think the specific scenario should be so different, I think.
I think the thing is that you need to treat it as a piece of research. You're making the argument that somehow human behavior is important. So I think that the important part is, well, how do we recognize pattern of human behavior in an agent-based system.
Okay.
And I use the example of dance because dance, for example, would have a certain ritual. If I'm at a Greek wedding and we're dancing in a circle, you would understand the relationship of basically all of those individual units dancing in a choreography around something. If I was in a forest fire, or, God forbid, in a bombing or something like that, you would understand the random behavior and the immediacy of dispersal, right? These are obviously very different scenarios, but the point is more about capturing human behavior and time and response to something like fire. Disaster is one example, but I think more profoundly, it's about pattern in human behavior and what that can tell us in terms of its relationship to something like fire. Does that make sense?
Yeah.
So the everyday, I think, in the context of fire is, I'm not sure what the everyday is, because we usually think about it in a very controlled way. Like I use the stovetop of my oven. Fire is not moving, I'm not responding, but you can even understand the pattern of cooking around that point source, right? My movement between the refrigerator, the sink, or my mother's movement or whatever. So it's about trying to make even the everyday pattern legible. There were some photography series that Diller and Scofidio used as an example in their book Flesh, where they were trying to talk. There were photographs taken about explaining the concept of modern appliances and how it would change the life of the domestic housewife. And what they did was this kind of long-standing exposure that would track the movement. And the argument was, with new appliances that you would buy, your movement pattern was much less, which meant that the housewife was doing much less work. And so the argument was visual, that new modern appliances basically meant that there was less work for people, and that would liberate the time. So just through an analytical photographic series, this is the way that people were selling the idea of the relationship of new machines within the house. These were done in the 50s and things like that, where the dawn of the dishwasher or the oven. The reason I'm saying that is movement behavior was a way of understanding something.
Yeah.
I would say the same thing here. Okay, can we go next?
Yeah. And next we compare the influence of multiple light sources on the path of the group in the case of different sizes and intensities. And next, the two different passes of points going off together on the fixed side and going in the other direction, and points randomly appearing in the field.
Yeah, I think these kind of, this slide, for example, is not giving me really any information. First of all, it's not time-based. Like I said, it's very zoomed in, so I don't know really what the multiple centers is offering me as an organizational strategy. And it shouldn't be shown in one sequence. It's very difficult to see how the point sources are actually influencing the agent.
Okay.
Like, for example, how was it possible that all of the agents on the first time frame are moving from left to right? Why aren't they, some of them, moving up to go to the light source, for example? Meaning, like, as a self-organizational model, they should be attracted to the nearest source first, right?
Yeah.
So there has to be some guiding principle that is evident, and these particular studies are not showing that. Is that clear?
So you mean I need to make the picture more clearly? Oh,
I'm just basically saying, if I understand correctly, you have multiple sources of heat, right?
yeah.
So if I look at the first image on the left, with all of those sources, with those points dispersed in different places, the movement behavior, if they're being attracted to the light source, single direction, they're not moving in a straight line for them to be just all moving. They're moving to a source, right?
Yeah.
They should be moving to the closest source. Otherwise, it doesn't make sense that there are multiple points with different distributions and they're all moving uniformly from left to right.
Okay.
Am I misunderstanding something in the image?
I just want to show that the single all the unit from left to right, and when he go through the light field, and what will happen when the field is so full of a different kind of heat light source, and what will happen like that.
Yeah, I know that what you're saying is that you want to show something, but the only way to show it is that the pattern of the simulation demonstrates that. So, for example, the agent should be responding very dynamically, either being attracted or repelled by the light sources, right?
Yeah.
So that has to be very legible. So either the movement behavior will spread around the light source, or it will be converging to the light source. And those are the two behaviors that I should see, and those are not legible here. So either the light source is really not influencing the pattern at all, or the agent, and that's a problem in terms of intensity. And so I think these should be done really as animations that I see. And the time frame,
okay.
Right now, all you're doing is mapping the point. That's where we get the trails from.
Okay.
It's very short. So I don't know really what the meaningful organization is.
Yeah.
Does it make sense?
Yeah.
And what are you doing this in? Is this in Unity?
In Grasshopper.
In Grasshopper. Okay. Can I be really honest? Can we do this in Unity?
Yeah, but it's more difficult to in the Unity.
I know. But why are we doing agents in Grasshopper? Do you know the studio basically invented agent-based design, right? Like 20 years ago. And we never used Grasshopper. And there's a reason for it. Grasshopper doesn't do this work very well.
Yeah.
That's why we brought processing into the studio. That's why we used a lot of animation software. And that's why you could do this in Maya as well.
Okay.
Is somebody telling you to do it in Grasshopper?
Because we do the simulation in the Unity, but it's too difficult to show the final thing. So we changed the Grasshopper to make it. And actually, I think we need to put all these things into the Unity, but now we haven't done that. So, yeah.
Okay. Okay. All right. I think my points are still quite clear that the patterns that are emerging here are not really reinforcing the relationship between attraction and repulsion.
Yeah.
So I think regardless if it's Grasshopper or not, those things need to be much more legible. But realistically speaking, if the problems are regarding Unity or the problems are in software, we need to address this more explicitly with both Mustafa and Alex. Less so with Octavian, but because he's really just a software tutor, and see how we are going to be working on this. So these particular sketches, I think at the moment are not speaking to the larger organization, and they're not really speaking too much to the relationship between agents, right? So if I'm looking at the pattern at the moment, unlike some of the earlier diagrams that you were showing, the network between the agents and some kind of control parameter that was limiting the space between them, here, for example, it's difficult to see if that rule set is still at play or not.
Yeah.
Between the agents, the spacing between the agents, or the constraint in terms of the movement, to think of them as a kind of collective instead of individuals within time and space. Does that make sense to you, or is there something?
Yeah.
All right. As long as you understand the concepts, then we'll find the best techniques for you guys to use to communicate that. But I want us to be very clear. If an image or something is not really communicating those things, we have to change the variables, even in the grasshopper definition, or in the recorded animations of these things, so that, you know, I don't care if things are just like recordings of your screen or whatever. You don't need to make everything rendered. I just need to see the behaviors, and I need to see how we're thinking about control and how are we interpreting this. Because, you know, fire disaster is a very specific.
Yeah, but actually, I think when we talk about a fire disaster, we can discuss the behavior of the human in the how they escape from the high temperature like that. I think we can use that.
I think the thing is with me, you know, I think we're not trying to just visualize the obvious. We're trying to express the relationship between pattern and behavior. And pattern and behavior will have different kinds of concepts of agency. We're going to talk about human agents, right? But we're also going to be talking about your architecture as agents as well. So we are going to have multiple populations of agents that may have different behaviors attached to them. But that's why we call it an ecology of things, right? Because we start to see the relationship between, you know, how humans are interacting with your concept of architecture, and how that is really understood in very different circumstances. Like, of course, if there's a fire disaster, people are moving away from fire. So I don't want you guys to be somehow called out like, okay, it's a disaster, so I run away from a burning forest. We're talking about something different in some way. We're talking about the relationship between scale and magnitude and control. Fire is something that is the most direct thing that we can understand, that magnitude has an influence on human behavior. If the fire is controlled, we celebrate, we congregate, we sleep next to. When fire starts to become out of control or the scale changes, it becomes very, very dangerous. And the human behavior is completely the opposite. But the range between controlled and uncontrolled is very small, right?
Yeah.
So I think the things that we're looking for is how do we use that concept to be able to start to deploy a strategy that allows us to think about these things spatially. It's not like to try to make something uncontrolled so people are repelled. We don't need the excuse of fire in that sense. We're trying to develop a strategy for systemically looking at how these things can interrelate with each other, right?
Yeah, but
Okay.
I think it's only a one kind of scenarios.
I totally understand it, but it's one that you've done now multiple slides on fire disaster and the unity thing about like fire escape and stuff like that, which as a simulation strategy in very real world things, those are done all the time with agent-based systems because of fire escapes of buildings, for example, crowd simulations that talk about how a building will function with multiple exits. It's very much part of the simulation world when it comes to fire disaster, because a very real problem in the built environment. So basically what I'm saying is that particular science of repulsion based on fire emergency is very clear. So we don't need to abstract it so much. We need to understand what we mean by dispersal in our world, in our architecture, which is not so much about emergency, but it's really about thinking about different ways of thinking about how the system self-regulates. Okay. Understand that the same techniques you guys were using were also being used for dissipation mapping and things like that. So there's nothing specific in terms of the indexical mapping, but so these titles become much, much more important in some way, or a distraction, depending on how we are interpreting it, right? So if I'm looking at this as a simulation for fire disaster, I ask myself, well, how? What's the point of disaster? What's the path that's being used? What are the obstacles that are being negotiated? That would be my line of thinking. Does that make sense?
Yeah.
Okay. Okay, keep going, guys.
So, Yunpeng, next.
So next step is about energy harvest. Okay, nice. So by comparing the temperature of the environment with the temperature of the human body, and judging according to the self-regulation ability of the human body, the corresponding behavior is needed to obtain energy or escape from the human body. So the step 1 is detect ambient temperature. The step 2 is detect human temperature. Step 3 is detect temperature exchange. And step 4 is make a judgment. This is a mechanism of the agency. Okay, next. So our living environments can't be separated from the building streets and crowded shopping malls, where in real time, thermal radiation will react to the human activity range and the limitation imposed by the public space, a space with warm people versus warm materials, and these temperature values allowed us to re-understand space and design it.
See, this image, for example, I think, different from the previous image. The previous image kind of talks about very generic ideas of having a radiator and these kind of elemental things. I think this can disappear, honestly. I think when I'm looking at an image like this, what I think is really powerful is that, technically speaking, the machine doesn't make any distinction between human and environment. We read the human in the environment, right? Because what we're doing is reading heat. And I think that this is a very important thing. For example, most traditional architecture has a very particular figure-ground relationship. The way that we engage, let's call it in the game of architecture, is to understand boundary and site, right? Those are the rules of street versus plot for building and these things. What an image like this does is, like you say, living environment cannot be separated from the building, streets, crowded shopping malls. And it's not just about its representation. It's just about understanding a very different concept of understanding our city, right? And I think that this is amazingly powerful for a thesis, and we have to find a strategy to really start to use this technology. This is my real feeling, like, with Apo and things like that, like concepts of photogrammetry, concepts of looking at some of this kind of information and data, because it's changing, right, in real time, is potentially a very powerful way of thinking about modeling an environment and modeling our architecture. Meaning, like, just like the weather system having like yesterday's weather is not really that important, right? Like nobody holds on to the data set so much of just random days and what the temperature is. I mean, we do now because we keep data on everything, but that's not so important and so meaningful. What is meaningful is how today influences tomorrow with probabilistic models. So the concept of future here is very powerful because that's the concept of something that's dynamically always changing. My concept of tomorrow is based real time on the concept of the pattern today. So when we're trying to make an architecture, in your case, that is anticipatory, we need to think about this kind of way of thinking about what adaptation or anticipation is. So that's why I think this kind of technology, I think, potentially can be very powerful. But I want us to really interrogate this also in terms of the kinds of techniques. How can we translate thermal mapping or 3D scanning strategies into new concepts of thinking about the environment and the terrain? So for example, a point cloud is not just some concept of just making an aesthetically different kind of reading of the city. It's about thinking about points in space that can be mined for very different concepts of boundary. Basically, deny boundary. Think about architecture as a fully gradated concept. It's closer to the concept of the blur and closer to the concept of other things in terms of the idea of making a distinction. Like if you look at the picture of the house on the bottom left, I think this is a very important image. We have the reading that it's a house, right? Because actually the machine can't delineate house. Or the machine can delineate body, but mostly because it has an algorithm that's looking for boundaries of the color values, like a blob detection. So I think if we take those things seriously, it sets up, I think, an interesting problem. My dog woke up, so she's saying hello to you guys. Okay, next.
Yeah, so faced with different scenarios, we try to seek ways to funnel human interaction with convergence, and the bird flock algorithm involving self-organization involves self-seeking, making judgments in the face of different behaviors in front of agents, feedback of behavioral data as a guideline for design. Of course, the input here may be a warm or not warm building or frequently used space. As always, mechanism exists. The feedback from the behavior, making judgments, adjustments, and then feedback to the behavior or design.
Okay, can I make 2 comments on this? First of all, I think I don't really understand the representation of these large cubes. It looks like large kind of Amazon boxes that are just kind of moving to a body or stacked together to have a representation of a wall. I think we destroy this concept of wall column is not helpful. And the aggregates should be much smaller, right? Because you're talking about something elemental. The form should not be so geometrically understood this way. Because right now it just looks like you're making some kinetic blocks that are interacting with a human. You're not talking about something that's a gradient, like a cloud over the human, right? So the voxel logic of the previous image, the potential of that, should be a similar kind of reading of volumes. That there is no volume, it's almost like dust. So I would make the aggregate smaller, and I would not have them combine themselves, like for example in the middle image, into a wall, because that looks like a generic kind of concept for like interactive architecture, right? And we're not really talking about that kind of feedback. The feedback has to be much, much more, how can I say this? The feedback has to be much more like how we respond, you know, for example, the difference between sitting in the sun on the hot day or moving into the shade. You know, the shadow is continuously changing. We are self-adjusting. This kind of much more intuition around the concept of environment, rather than seeing it as a kind of, like, what's at play here is that it's almost like a kinetic, robotic moving box, right? And if you ask me honestly, I'm not sure if that's what you want to do, but at this stage, it seems a little bit premature. But that's the reading that somebody would have. Does that make sense to you? And I would deny any kind of thing that looks like a wall or a column. Deny it as a starting point. I would much rather see it as a volume that is amorphous and that comes into form, so that you can speak about things that may have informal organizations that can get formalized around the body. And that's why I also think the body has to be abstracted in a way, like in the agents, as a point where you can start to see these things as centers and ranges. And that range doesn't have to be, you know, just a bounding volume of a sphere that agents are running in, or a circle. It just has to have a clear distinction about what a polycentric relationship is. What is the point at the center of the circle? Here, it seems like the point is a human in this reading, right? So the organizations of that should be much more spatialized around the concept of the human and the human behavior. The difference between a moving human versus a human at rest should be in the ways that these elements are reorganizing themselves around the human or in front of the human. It should have some kind of idea of task, but it should not be like, okay, we're going to make a hypersurface, so it's a screen. It's not this kind of stuff. You understand what I mean? Apo, do you agree? Disagree?
I agree in this sense. I'm not extremely clear about this behavior, to be honest.
Well, at the moment, there is no behavior. That's my point.
Yeah. So
that is really tasked around it. So the interpretation of this is more like a reactive system. Like I have a human doing something in front of the wall, and the wall is going to do something. It's not more about like heat and the things that are more gradated that influence the human behavior, right? This has architecture as something separate from the human. Think about architecture and human is one thing, like the thermal reading, no distinction. Distinctions are gradated. The body has a radiation beyond the physical boundary of the body when I understand it in this way, right? Okay, keep going to the next slide as Apo can comment as we move on.
So as we all know, the space temperature of city depends on the repeatability of the route that people walk. That is to say, the energy gathered by crawls also reflects the utilization rate of the urban space. For example, the high temperature for urban space and the low temperature for rural space reflect the prosperity. So from the perspective of architectural language, this can be judged as a data of design. And the temperature of a crawl is dynamically changing and behaves differently as the space changes over time, which is another design rule for the space.
I mean, for example, couldn't this be your architecture? Instead of having concept of a wall, couldn't I look at this gradation as this kind of voxel logic of field, a gradated field?
Yeah, you know, I mean that the crowd of people will have the high temperature, and they will have the same route.
Yes, yes.
And maybe, yeah.
I'm talking about in relationship to the previous slide. For example, when I look on the left-hand side and I see this radiation bubble around people, it seems to me much more appropriate than a wall as something that's already prefigured. But the ones to the left seem too much like kind of blobs around people. But the plan, I think, is much more telling of thinking about that in plan or section, that we have these kind of concepts of gradated fields. Because the color codification, obviously, you know, it's a heat map, all of these kind of things. But the color codification also allows us to mine that information for different purposes. So we can see it as an evolving real-time map. And then we could say, well, okay, if things are moving into cyan, what does that trigger in our architecture? If we can quantify how much cyan is within a particular range, and that may have a very different concept of triggering an event as well. If it's consolidated or if it's distributed, we have different ways of interpreting that information that may trigger different ways of thinking about how the architecture responds to scenarios. And that's where I think the pattern logic and the quantification of some of these heat map strategies can be a very useful way of thinking about it in a more direct sense of its architectural implications. Not as an analytical tool, but also as a technique of reading space that then can be formalized in some way. Keep going. Sorry, I said I wasn't going to interrupt, but you know, there was a point to be made. Go for it.
Tiny. So, Tiny.
You're mute, Penny. We don't hear you. Maybe your microphone is off or something. Maybe it's maybe you need to log in again. Checking the device. Somewhere it says where you get the sound from. You may need to change it to your laptop or something else. If you go next to the mute button you have down in the screen, and there's a little arrow. If you click that, then you get the options which microphone to use. You may not. Can you speak now? No.
Panayota, are you a Mac or PC? PC.
That's interesting.
I read it.
Just trying to think. I don't remember the preferences on the PC side so easily. But you should go to your system's preferences and just go to your sound. If you go to search for microphone. Are you wearing headphones? No headphones either. Fantastic.
Just log out and get in again. I think maybe it's something like that.
Yeah. Did you get my message for the video?
Yes. I got it. I think it's straightforward.
I know. Who's doing it?
I mean, in the beginning, I thought when I saw them, I said, the students being in the second page, maybe it's not the right thing, but then it made sense. So I said, why not?
I mean, I don't have generally a problem, but fading in and out 3 title cards as an introduction is not a great to the thing. It sounds like all the credit should be at the end.
The thing is that they kind of say that if you have more than 1 cards, put them in the row. I mean, but
is that what they said?
They say that. So if they cannot fit in 1 page, you need to put a second page, and they fade in and out. But I agree, it doesn't look good. So I think it's better to.
Anyway, I used it as an excuse to just include everybody in the DRL instead of, they just wanted 1 project. So I just basically said our studio was a project and Patrick's studio is a project. That's why it doesn't fit so much in the format. But I mean, technically speaking, they were supposed to do that stuff originally. But since we're doing it, I think it would look much better at the end. Otherwise, it doesn't make sense.
Yeah, no, sure, it's fine.
And he didn't answer me about the installation of the physical thing, because I think that's really what matters for the sound issue.
Yeah.
Online, I don't think it matters.
Yeah.
Anna, are you back?
Can you hear me now?
Yeah.
Yes.
Yes. Sorry, I don't know what's happening with my microphone.
You have a voice now, and we can appreciate it.
Yes, I was talking like in the middle of the conversation. I was generally, while you were making comments, I was answering some questions, but apparently no one could hear me.
Yeah, sorry, I don't see it on the screen.
So we, after looking at all the ways we could harvest energy from the human, we wanted to also research how to maybe harvest energy from the environment, like the sun, outer space, and soil. And we found some very interesting researches that have been done. So while solar power systems have offered a wide variety of electricity generation, approaches including photovoltaic solar thermal power systems and solar thermoelectric generators, the ability to generate electricity at both the daytime and nighttime with no necessity of energy storage remains challenging. So in this case, a sustainable and cost-effective strategy is proposed of harvesting solar energy by solar heating during the daytime and by harnessing the coldness of the outer space through radiative cooling to produce electricity during the night using a commercial thermoelectric module. Next, please. Yes, so from the thermodynamic perspective, there must be a hot reservoir and a cold sink to produce useful work as a heat engine for any kind of energy conversion process. So the solar thermal power systems use the sun as a hot source and the surrounding environment as a cold sink to generate the electricity. So the sun, the soil near the Earth's surface, and the outer space are 3 separate locations with a huge temperature difference. So radiation heat transfer builds a bridge for these 3 locations through solar heating and radiative cooling. Solar heating during the daytime, and the ubiquitous and easily accessible sunlight serves as a heat source, and the chilly soil at night acts as a cold sink to build a temperature difference for the heat engine to function. I think we were starting to look at these things because we started to mention that we could be doing some experiments now, like prototypical experiments. So we also started to think about what in our, like for our team, in our case, what we could try to do with heat, like generally at home, like starting to do small experiments using maybe soil or some sort of heat source to see how we could use the data we find, some information that we could maybe use in a useful way for our simulations. in the next step. And then I think after that, we have the material next.
Actually, we haven't.
I've shown you this.
Yeah, actually, we haven't done the material part, but we want to do the next with the, cause we got the whole material, the meta material. So next step, we want to find how to form the whole in the use the material like that. So, okay, that's all.
Okay, guys, can you just put all the slides up? I think we talked a lot about the first 16 slides, so move towards the last 10, 15 slides. Okay. I think realistically speaking, I mean, scroll down more just so I see the final slides too. Is that it? 25? Okay.
Yeah, 25.
All right. I mean, I think we need to be pushing this a little bit further and faster, and I think really start to take some decisions about things. I think the comment, for example, on slide 23 was you were basically setting up the relationships, and basically what we're talking about as a whole or any of those things there was no unknown to that, right? And that space in some sense was solid, and you were generating a void strategy through the pathing. Do you remember this conversation?
Yes.
Has something changed since then in the interpretation of these things?
I think mostly we focused on the flocking part of the previous presentation.
Sure.
Because we had done all these different experiments on material, like different types of materials and the porous material, and we thought that after, I think, everyone's comments, the last part with the flocking was something that we could move forward with. So we don't know how to introduce heat in this scenario, like maybe as a material, or how, like in this cube-based, let's say, approach that we had in the previous slides.
Like in slide 23, 24, or whatever, the issue of the cube, honestly, is not an issue for me in that context. The issue becomes, because I read it just as a volume of space, right? Could be a volume of air. It's a way to index it. When it becomes a problem is when you guys make it into a design aggregate, when it's like slide 18, for example, when the cube basically becomes the proxy object, and I see moving cubes. And in this presentation, for example, I think the most powerful slide where we had, or 2 or 3 slides that you had, which were these floating cubes around the body, is not in this presentation, for example. Which for me is also a little bit telling that maybe it wasn't totally understood what that slide or those slides were about. Because in some sense, it made the question that those voxels or whatever it was, those flying things around the body, I mean, we don't know what they were, but it was clear that potentially it was some kind of concept of architecture that we don't know. There was some attempt to kind of create space potentially, but it didn't have the resolution. When I look at slide 23, if you zoom in there, you talk about porosity, right? Go to 23, 24. Can you click on it? Yeah. So, for example, if you remove the title now of material experiment, and I asked you to define what porosity meant in terms of space, what does that mean for you? So if I was to interpret what I see in slide 12, it's undifferentiated space, almost like a sponge, right? It has not one axis, every vector is somehow absorbed into the system. Like porosity in this case is a very generic version of porosity, but I think this concept of undifferentiated space, I think, is important. In for example, the bottom sequence, right? In the top sequence, where I just have very clear solid void, in a traditional sense, I see those opening of those tiles, the black tiles, at void, and I connect one tile from one face to another tile. I have some kind of logic of path, right? Which is basically what the simulation is. So if you had to consider what we've just been talking about for a long time, and let's go to slide 25, or go to 24, 25, so we click through this. Once again, if I'm looking at these images and I said, you know, this is your architecture, this thermal image, how would you argue porosity in that world? Remove it from the concept of material heat dissipation. I'm just thinking, like, if I look at slide 25, it seems to me closer to what an architecture could be, but it privileges an existing world that I know, meaning like walls and floors are very clearly delineated, which in some sense, if I have to interpret the environment, the built environment being a connection to the environment in your case, it's the world that I know. It's an architecture that's quite finite and stable, right? And if I had to ask you what your architecture's attempt to be, coming from the elemental fire thing, it's quite time dependent, right? It can emerge and disappear. I mean, that's the beauty of those things. The fire goes out in the campfire and the event is over. The architecture disappears. And it can reemerge again. So I'm just thinking about it conceptually, and this is where I need a little bit of feedback from you guys. But I think when we're looking at the agent-based work and stuff like that, it's not to do generic agent-based design. It's really to start to think about how change happens, right? From a thermal camera reading in one still, there's no change. From a video of a thermal reading of an everyday scenario down the street, everything is constantly changing. The important part of including the human into the conversation is not to harvest the heat from the human, like the same way that we would be harvesting the sun. It's to just understand that the human is also a source of heat, right? So if we put this filter of heat as a strategy, we would have a very different reading of the city. And we would have very different concept of localizing even the concept of what a site could be. For example, an ex-student of a very close friend of mine, who's an artist, did his graduation project at MIT with Christoph with this concept of developing a homeless shelter. And what he did was just really acknowledge where heat sources were in the city. His name is Michael Rakowitz. And he made these inflatable pods with a tube. And he basically said, well, there is all of these exhausts from restaurants. There's exhausts from the sewers that are sources of heat. If I can capture that, I can create an environment which is warm. So he designed his homeless project, his homeless vehicle, as something that was really harnessing the device of existing kind of heat sources in the city. So for example, a restaurant that's cooking that has an exhaust that's coming out is pushing hot air out into the street. The subway grid, from the heat that's happening in the subway that's coming through that to ventilate the subway, creates a heat source for homeless people. And that's why usually you see people sleeping on top of a subway grate, because it's a source of heat. So it's a very different way of thinking about the city when you take it from that perspective. And I think technique-wise, this is where I go back to the thermal imaging and maybe concepts of scanning, as thinking about it as discretized ways of thinking about information. I think it's very powerful. And thinking about the agent systems as actually how humans and architecture are moving and affecting this, I think is very important. So I think the agent-based systems are basically trying to at least identify two populations that are interacting with each other, human and non-human. Non-human, I would call architecture. Human, you can keep it in a conventional sense as a person, or maybe this is not the real best way. Non-human, I would call environment. Human, I would call human, and the interaction between those two things should be called architecture as a diagram. Does that make sense better?
Yeah, I think the reason why we used the cube was definitely not to resemble like an existing architecture, like a wall or a floor. We started from this a voxel-based strategy from the beginning of the project with all the pathfinding simulations we had, and it was just an object. I mean, we debated whether we could have used a sphere instead of a cube, but we still don't know what like this interaction will be between the human and this object, which we don't know what shape it will have, if it's going to be like the same thing, like many different cubes or spheres stacking or different shapes. So I think it's still pretty unclear what this like relationship is going to be.
That's for sure clear in your presentation, but I think that the point that I'm trying to make is that we're not somehow provoking a response to be able to clearly make that more legible, right? So, for example, I've mentioned Philip Rom many times, not because I really love his architecture or anything, but I think he makes attempts to somehow think about that kind of indexical volume of voxels, right? So for example, the space here is a volume, which is like a proto-volume, but the space is delineated. It's not the issue so much about cube. It's the issue about actually trying to find techniques where that concept of gradation and source can be really articulated almost like building the simulation, right? So when he makes this kind of diagram, this is not, having a toilet and a bathtub in this and just putting a gradient filter on it is not what we're doing. But when he's starting to develop these kind of concepts, these are just very simple kind of heat map strategies, this is closer to what our architecture would be like, right? So for example, like when I look at the voxels, the voxelization by itself, if it's taken too literally, basically makes a series of bricks and aggregates in the space, right? If the resolution is not fine enough, what we're generating is something that is much more traditional in terms of an aggregate that's stacking and it's, on top of it, like, and that would lend ourselves to more robotic things. This kind of concept of an architecture, even if it's more sketch-oriented, is more amorphous, is gradated, right? Is the boundary of architecture the white or this really cyan blue? And I think it has an implication on how we think about design. And I would like you guys to think about it. I mean, this is actually, for example, one of his manifestations. And this one, I think, is actually probably one of his most successful ones, because in some ways, there's two things. He's got these like heat light sources, and then he has these illumination elements. he basically builds the 3D voxel space with those things distributed with this kind of conduit. But you start to understand the field. What's not interesting is this kind of stuff, because this just looks like a minimalist kind of art installation. These spaces are not really zones that have different effects. So if I look at this, not good. If I look at this, much more interesting. From my perspective, right?
Theo, I don't know if you're sharing your screen.
I am.
Okay.
Nobody's seeing anything that I've just been talking about?
Because I do see the previous one.
Okay.
Yeah.
So can you guys unshare your screen? I'm going to try.
Now we see. Now we see.
Okay, sorry. Anyway, the thing that I said was more interesting is this thing on the right-hand side. What is a really bad version of the same kind of diagrams is this kind of thing, where this thing becomes this kind of kitsch idea of kind of different volumetric spaces. This one has a series of conduits with these displaced kind of heat sources as an example, right? He's literally trying to build an indexical model. When you start looking at these things, when he starts putting bedroom, living room with just a gradation, this is complete, let's call it what it is, bullshit. But when you start to see more, you know, this kind of world, I think this kind of world is much more true to form, let's say, formation. So the point is, well, how do you actually generate an architecture like that? It's not by saying this is a piece of plumbing here, so that's bathroom. I mean, that doesn't change the concept of architecture at all in that sense, right? So we have to be looking at strategies, and I think when he talks about it as a meteorological concept, it's more the concept of weathering. And I think that there are some examples of this which are interesting. Now, you know, he's been working on this kind of strategy, which I think is important, and these kind of indexical models, which I also think are important. When he takes them to literal, like he designs systems that are not so interesting. When it's much more abstract in terms of indexical notation, I think that they become much more powerful. But I think for sure this is much more about a three-dimensional volume that is much more like trying to make this legible. It's not trying to do like what he's doing in the park, which is a complete failure from my perspective in Taiwan, where he just put some gradation field saying this is going to be cool, that's going to be hot. It doesn't really work like that in an outdoor environment, right? So even the difference between inside and outside matters. And when he tries to do it outside, it just becomes a piece of heavy ductwork. We don't want to do this kind of architecture because it just looks like an M&E. Let me see. Sorry, my spelling is not very good today. Like, from my perspective, I would see, you know, a couple of the projects moving a little bit more in this domain, right? So, for example, he has done a series of projects which I think are pretty interesting. I know that you guys keep focusing on heat, but I think we cannot separate heat from light, and both of them kind of speak to different kinds of concepts of structuring space. And I think they are also helpful of transforming that kind of gradation concept into a physical manifestation by thinking about space as atmosphere. And if you look at some of the things that he's been working on, I think they're quite powerful. But I also want to show you this piece because I quite find this quite fascinating. It's called Snow. And all it is a series of fans moving basically all of these feathers within an environment. It's like literally building a giant simulator, right? Now, obviously, the human isn't inside of that. It wouldn't be a very nice environment to be in all of those feathers. But the concept of space making, I think, is somehow interesting in terms of generating this concept of blur. So I would say have a look a little bit at some of his work. I think that there are multiple examples, even kind of examples in terms of just like looking at concepts of illumination that are maybe a little bit more different. Like, I think he always tries to make stuff, at least the ones that I really enjoy the most, are always these kind of very immersive and illumination-based gradations of spaces. Like from all of the teams, I feel like your team has to move into a concept that is really thinking about field and much less about aggregate. And I think his techniques of doing that with like a simple window and with shadows and everything, and this kind of gradation, I think just starts to speak about something that's much more ethereal. So I know that you guys keep talking about heat, and I think heat is important, but I don't want us honestly to fall into the trap because of some of the simulation logic that heat and light are just like two separate worlds, because the campfire and all of those things reinforce something different. So Philip Ram, for example, is much less gradated and much less atmosphere than this guy. This guy doesn't talk about those things, but even something like a simple obelisk or a bottle, you know, this is a bottle of Dom Pérignon, whatever. Not that I drink a lot of champagne, but you see the effect of all of that stuff around it. So even what's an attractor and a source, I think that there is something quite powerful about those things. So long story short, I think he works with very particular kinds of concepts of these things, which I think are very powerful and beautiful. So I would maybe take some inspiration, I guess, from him. And I would also suggest, like, the technologies that you guys have in terms of harnessing the sun, I think you should think about it as a distribution strategy that potentially could be working this way. Like, could this be a way of capturing and harnessing the sun? Or does it have to be something like a foil? You're looking at different technologies, but look in terms of how those things can be deployed in the world. So, you know, this concept of field is very different than other concepts of field, right? That's very different from this concept of field. Do you guys understand what I mean by this? And one last thing, which is one of my favorites, and Apo is going to be sick of it. Have you guys looked at Hod Lipson? No? Okay. Please look at Hod Lipson, because I think that there's also an interpretation of voxelization as physical aggregate that doesn't change. And he's done, I think, some very interesting research on soft robotics using voxel-based representation, which I think has been, well, I think it's game-changing. I think it's always been game-changing. We've used it as a strong reference in the studio. But I also think, like, for example, this is just simple expansion and contraction, but he's basically using it in simulators to talk about how through expansion and contraction we can have some concept of mobility. So when I'm looking at some of these kind of animations where the cubes are just migrating towards a human, I would make them much smaller, many more, and have them think about their concept of movement. If it's more dispersed, it's more like atmosphere. If it's more concentrated, it has behaviors that are much more transformative and localized. Mariota, am I confusing you guys, or? We've lost you
I
again.
don't know. We looked at so many of the Philip Brown projects, for example, and we included them as case studies in booklet. But like personally, what confuses me is that like Philip Brown has he has like a context, a setting where he like it's a room or an apartment or like a specific space, and I don't know where we will like introduce this strategy or how, because it's like we haven't defined a space. So I think it's more abstract, and sometimes it's more confusing to think about how we can like do what he does.
I don't, but I think maybe I've miscommunicated. I don't want you to do what he does. I want you to look at his diagramming strategies to show how he is describing space. I don't want you to do his architecture, because his architecture most of the time is quite bullshit. So, and I'm sure that you probably are struggling with why is Theo basically mentioning this guy.
And I think we're struggling with what space is, like what.
So I don't always show this kind of stuff, like at least my work. But for example, in an exhibition that we had in terms of a fashion exhibition that we were part of, we said, okay, what if we remove all boundaries between textiles and body and space, right? Enclosure. If we remove those boundaries, could we have an architecture that has no limitations between clothing and building? So in this concept, for example, clothing were swarms on the body, but they could also leave the body and extend themselves into, let's call it, a volume around the body itself, right? So the human, in some sense, would still be enclosed, but the relationship of the space between the agents and the body itself would be different. So the concept was like almost, you know, in a generic sense, it could have been more like an inflatable around the dress that would create a volume instead of the clothing on top of the body. But in this case, for example, just as a premise, the space was volume around the human, swarm on the body. And this was basically the way that we spoke to, you know, maybe the future of what fashion and architecture could be, because that was the premise, to basically remove that boundary. So concepts of space, I think, in very different ways can be articulated from very different perspectives. Philip Brown is using a concept that's not really about space, it's about sight. Right? So I think the issue about space and things like that is different. And I would suggest that you focus more on the concept of space. And that's why I think the heat maps and so forth, I think, for me anyway, are very suggestive, right? Like my project that we did was basically a sketch about what the future of fashion could be. But in terms of the concept of what you guys are doing, I would say focus on the concept of space making that's both singular and collective. And the hot lips and stuff that I'm showing you is really about taking the concept of voxel and not treating it as a finite aggregate, right? Because you're treating it more like some of the history of the studio, like Hypercell and projects like that, because it looks like the cube itself is something that's going to move and reassemble around the body. Try to think about how that relationship with the human body can evolve. You know, it shouldn't just be like a pod around the human. That's why I'm showing you like the things that Yoshioka does, because in some ways, light, for example, here in this image, the actual cells that are generating these gradient patterns really don't have that huge impact in the space, right? But because of the trajectory of the sunlight coming through it, they become the optical projection. So if I had to do a drawing of this, if I draw just this grid of lenses, is not really speaking to the quality of space. The space is just using that almost like in a phototactic way, knowing the pathways of the sun, capturing that through a vessel and dispersing it in a different way. So I think that would have an implication in terms of experience, but it would have a very different implication in terms of harvesting. And the only point that I'm suggesting in terms of the field is having a changing field basically allows human occupancy to be very different. Like, I find these installations like really fascinating because they are both immersive, but they also displace perspectival views, right? If I'm looking at the space, I know the aggregate of what it is. We've done installations like this too, but the way, the scale and the magnitude and the volume of material just makes this now into like a landscape. I don't privilege path like corridor. There's no concept of wall. It's just a gradation of volume. And I think that these are positive ways of thinking about translation. I could also imagine this landscape moving. Now, in this case, obviously it doesn't, but movement doesn't always have to be physical. It can also be perceptual. As I move in this landscape, you know, this body here, I can't really place where the human is, right? Where is his feet? The depth of field is not so clear. So it starts to play, I think, interesting games. And for sure, if I can bring together the concept of heat and light generating that attraction and repulsion, I can think about organization of materials that can amplify that. And I think amplification, I think, is a useful concept in your project. Apo, do you have something? Or you may have other references. I don't mind being the reference.
Well, I think the important bit here, and I think that's what Panayota is struggling with, is how to apply it. Basically, what is the base scenario? What are they trying to do? Which I think, I mean, it's understandable. It's a bit complicated, but I think if you think about redefining public space, for instance, right? If we start from something as simple as that, urban space, what is it? And how can you actually give a totally different experience? Like at the moment, public space design is a tree, some water feature, a fountain, and a big space, and that's it, right? But what else can it be? Here you have a great opportunity to actually play with light and perhaps different temperatures to define space. And that could have this kind of interactive, let's say, approach and adapt to human movement, adapt to human preference. And it's actually could be quite interesting.
I just want to go back to the concept of sponge 1 second. You didn't say that it was sponge, but you spoke about porosity. Now, I just make one connection to the stuff that we just saw, Tokujin Yoshioka, right? So he has a lot of these kind of straws that he's using. He uses very everyday things. But for example, in nature, the concept of the spicule is where a lot of the concept of sponges come from. And if you look at them, they are discrete elements that aggregate together. If they aggregate in certain forms, they start to generate geometries. And the most kind of exquisite versions of that, where you really start to see a concept of sponge like lattice, is when what people are calling glass sponges, right? So for example, this is an example of spicules in an informal relationship. This is an example of spicules starting to formalize. And if I just type in glass sponge, for example, this is what's happening at a much larger level. So locally, those things can be organizing with different patterns and becomes much more of a lattice. And colonially speaking, in terms of organizations, they'd be organizing themselves at this. So as you're zooming from the local aggregation of voxelization to zooming out, you start to see different kind of emergent patterns, right? Different morphologies. All of this kind of stuff is just speaking to a very different concept of resolution. You usually see them as these linear things, but you could also see them as these kind of self-forming elements. So they grow linearly when they have a surface to connect to, or they grow radially when there's actually no context in some sense. What I think is important to understand is that the genealogy of this studio speaks to context and environment as really informing the self-organizational rule sets. So the default of having a, what we talked about, polycentric model is to understand that there are many centers potentially. This one has one center, right? That's why it defaults into the sphere. But if we close this one and we zoom back out a little bit, these kind of organizations are polycentric, and you can see that much more legibly. And then when you introduce concepts of growth and things like that, then you get something totally different. So the sponge on the local level and the sponge on a global level as a collective organism or as a field logic continuously evolves that definition of porosity in some sense, right? And that's the kind of way that I'm thinking that you guys should think about it. When you look at it like this looks like much more of a traditional sponge. When you see it as a series of kind of growth and rule-based logics, and you start to look at this kind of world, those individual little spicules are organizing themselves and creating different concepts of porosity. Now, I'm just using this as an example so that you can understand that porosity can be interpreted in different ways. Some of it can be materialized. So yes, this looks visually porous, but from the perspective of heat, this is about controlling dissipation, right? If I interpret the glass sponge as a chimney, I can control in a dissipative way how heat will rise through a system and how it will be extracted outside, right? Like a chimney in my house that I'm at the moment in. It's a fluting system, and there's ways of thinking about this kind of idea of dissipation. So I just want you guys to start to think about that stuff. But I think porosity is not something that was a bad word. Porosity, I think, is an interesting word. Just the same way we need to attract heat, we need to dissipate heat. And you guys have done a lot of simulations in terms of material logic. What you haven't done is introduce a distribution of material logic. So that same kind of algorithm, which is just one bunched up cube, could have a generative logic of distribution that introduces porosity spatially. And then that interpretation would be closer to your slide where you're showing me that kind of minimal surface porosity sponge. You understand what I mean? That's a generic cube that looks like a kind of minimal sponge-like model, minimal surface strategy. but it has no environmental input. You introduce environmental input, and all of a sudden now you get very different topological growth strategies because you're introducing a new criteria. The heat transfer logic is still the same, but it's being deployed with the concept of growth. So it will recalculate every time it meets a kind of endpoint where you would reevaluate its kind of heat-based dissipation logic or any of the kind of algorithmic processes you guys are working on. But I only show you the spicule that then organizes itself in a different way. You wouldn't notice that this is a grid-based logic of organization because the morphologies of what's happening is really not grid-based. And it's because the resolution is much smaller. So we don't focus on the issue of cube or sphere, we focus on the issue of resolution. So think about your space as high resolution space. Does that make sense? Let's put it this way. I feel like you guys are going to break out one day and have this epiphany where this stuff just kind of starts to be deployed. But I need you to kind of understand that generative strategies are important not because we're choosing agent versus voxel or that they're different. It's that we're trying to find a way to think about how we can introduce logics within the voxel deployment that are more generative design oriented. Apo, are we on the same page or?
We always are. No, we are. I mean, I agree. I still think the team needs to figure out what, like, shape a little bit their base scenario. What are they trying to do? And that may give us, that may give them quickly a kind of a wider side of things and how they can use the little research they have done, because they have a lot of interesting pieces, but they cannot bring them together. But I think all those are extremely interesting.
I agree with all of that, and I'm not suggesting otherwise, but I'm just trying to, I mean, Dagam's simulations from back in the day, I think, are useful. I mean, for the Earth team, he's the one that, when we talk about the cracking simulation, stuff like that, you know, these kind of things are useful to look at. But for example, and Mustafa hates reaction diffusion, all of that stuff, because he thinks it's not computing anything. And in some sense, he's right. On the other sense, this is a voxel-based strategy. This is all voxels. But we're not really talking about cube because the resolution is very different, right? If the cubes are small, like what a voxel is a 3D pixel, right? And in this case, it's a 4D construct. What's important is not that the origin point is a cube. The point is about how those voxels are starting to algorithmically give us information. So when you see this clipping plane moving up, it's calculating step by step. The reason that it's three-dimensional is because literally the interpretation of that plane is being kind of given as a memory model and is basically being moved, generating layer by layer, like if you were doing a 3D print. So I don't want you guys to get too stuck on the concept of cube. I think we need to make sure that we are focusing on the concept of voxel as a 3D kind of discrete notion of volume. That allows us to be able to deploy it at different resolutions. Does that make sense? So, I mean, this kind of example, I'm just mentioning it to you because it's just 100% voxel-based strategies. What's allowing the morphology to change is a reaction diffusion algorithm in this case, right? So we wouldn't be able to understand voxelization as something dynamic and changing unless there was an introduction of a different rule set that spoke to distribution. The point that maybe Mustafa and I disagree about, which is a point that actually is an interesting point for you guys, is what instigates distribution of voxels. Mustafa's research with you guys have always kind of given that bounding volume is a full condition of voxels, right? And this is where the difference between additive and subtractive could be made, or actually is not really an issue at all. Here, for example, what we're looking at could be the subtractive, or it could be the additive thing. It's an interpretation of what you see, right? There's an inside and an outside to every volume in that case. The difference is, well, what's generating that volumetric difference? Up till now, you guys have been doing this path simulations within that, which is creating strands within the cubes, almost like literally eating out void. This one is different. This is saying that, okay, each voxel is going through a chemical computing strategy with its neighbors, and that's where you get these radiating, dying cells, emerging cells, you know, similar to kind of game of life logics and other things. But these morphologies are 100% dictated by a different algorithm. The color mapping, for example, could have been heat, for example, right? As this shape is changing, based on the rate of change of the volume, heat dissipation could be a reading of that bitmap. So you have a very analytical way of looking at heat transfer, but you're also introducing concepts of porosity and other things. And then I also think your project, and I would say the Earth project, are very field-based projects in my interpretation. So the field is what creates this concept of volume. And the field doesn't have to be visualized. It's just that perimeter that is allowing that kind of source. And if it's a cube or if it's a circular kind of delineation, it's the bounding volume, which is the playpen for your simulations. Okay? All right, I'm stopping to show this. Is it useful if I take a screen grab with the tabs on it so you could look at this stuff, or?
I've taken notes of everything, so.
Okay, great.
Okay, thank you.
Thanks, guys. Can we get the next team?
Yeah, could we be the next team?
Yeah, perfect.
Yeah, and Xiong, could you share your screen?
Yeah, please wait a moment. Let me share the screen.
Yes, please share your screen. Am I still sharing mine?
Wait a moment.你这个不行。你先开始。
Okay, shall we start?
Yeah, please.
Yeah, okay. Hello everyone, we are the Earth team. And next page, please. This time we firstly go through the PowerPoint quickly. And next page, please. We'll give the background of the unsurfacing and the pros and surfacing. Next page, please. And next page, please. And the next page. Yeah, and we add the timeline of the traditional way of construction from the primitive society to the Anthropocene and the post-Anthropocene, which is the construction made by clay and the clay printing. And next page, please. Sorry. Please go to page 8. Yeah. We could say that in the Anthropocene, the buildings built by humans shape the earth and generating an artificial landscape. And we do a study, and it shows that the gap between the building designed lifespan and the building real lifespan are quite large. For example, in China, the building designed lifespan is 100 years, but the building real lifespan is only 30 years. Next page, please. And what's more, the building material lifespan and the building lifespan are quite different too. This is a research shows that the 8 kinds of materials used in the actual building process. For example, the lifespan of the white mesh is 5 years compared to the 100 years building average lifespan, which means it needs to be replaced after 5 years use, causing the repeated material cost. Next page, please. Page 10, please. Sorry, page 10.
Sorry, maybe we need to go to another slider. It's the wrong slider. Good. Sorry, maybe I can share the screen. Just went wrong.
Please go to the next page. Yeah. And we could make a conclusion that in the primitive society, people built with the ramp earth, and architecture is symbiotic with the earth because the building materials are directly derived from the soil, and which creates a natural landscape. But in the Anthropocene, the development of the architectural design and the building technology And human-built architecture could be interpreted as the Earth's landscape, and now architecture is separate from the Earth because of the material waste and the artificial landscape. So what about the post-absorption? Next page, please. This is a scenario research that we done. And in the post-absorption, the development of the digital technology creates plenty of the unmanned factory all around the world, and which forming a non-human machine landscape and also a landscape of decay. For example, a new technology industry is staring deep in the rural China. The Bitcoin mines operated by the hydroelectric power from the mountain streams. And the Bitcoin is a currency that derives its worth from energy, and it requires the electricity to run the calculations that generate the new coins. And these processes have found a new natural home among the electricity plants scattered along the region's mountain streams. And next page, please. And another scenario from the view of the post-absorption is the film Blade Runner, which describes a lonely world where everyone who can has fled, and those who remain dwell amid the remnants of the environments designed for a machine rather than people. And this is the vision of the Earth in 3 decades' time. That is the backdrop to the film. Yeah. Next page, please. Yeah, and so we could ask a question: how do humans prepare for the post-absorption? And next page. It's the energy transformation and the symbiosis concept that we have already mentioned in the previous presentation. And next page, please. And next, we could go quickly to page 23. And as for the growth system, we regard the architecture as life, the building life cycle. So we take a look at the building life cycle, which refers to the view of the building over the courses of the entire life. Building is not just an operational building, but taking into account the design, construction, operation, demolition, and the waste treatment. So humans use the rimmed earth to build houses which can return to earth after being used. In post-absorption, in the context of the development of the artificial intelligence, although it is impossible to return to the rimmed earth construction of the primitive farming era, we could ask a question that can we develop a new strategy through the deconstruction of the logic of the primitive house and the termite mold, and let the building self-build, self-construction, and self-organization to realize Hello, could you hear me? Next page, please.
Guys, I think it's most important just because, I mean, you guys had made a very clear presentation before in the mid-review. it's just to kind of go through, I think, quickly what you guys have been basically doing since then, and also if there are key concepts that you guys want to focus on or you made more legible. Like I see Kiesler, I see some other things here, the termite mounds. Try to express a little bit more directly post mid review, because I think the argumentation for you guys was quite clear in terms of your thesis.
Okay, wait. Sorry.
No, go ahead.
We could go to page 26.
Yeah, so we do some research about the farm technique, since the traditional construction technology by human labor is not applicable for the machine landscape and the unmanned factories. One method is to use airdrop to drop living life as a seed to these post-industrial sites. Then we did research on the air seed technology. This is a practical example of farming technique. Using airdrops as a technique, an idea that originated in 1930. Compared to human cultivation, planting by aerial production is more efficient. The technology combats the problem of land degradation and global warming and is always in the side of constant experimentation. By flying at low altitude and projecting biodegradable seed cans onto the ground, plants can be grown in the soil when the external cans are rapidly decomposed. And here is about its machine that can grow plants on the ground. And here is the concept: the endless house gives us an insight into scaffolding systems where we need to create a proper space with a certain connectivity between the voids, allowing air and sunlight to enter. From this, we look to nature for relevant growth strategies. This includes mainly the anthill strategy for form generation and the mycelium strategy to support natural growth with sustainability.
So the next is the anthill has a certain structure, mainly related to the behavioral pathway of ants and the energy on which they depend on survival. Meanwhile, with the anthill system, a life cycle exists. It consists mainly of ants and bacteria. The ants feed the bacteria and encourage them to multiply in the soil, and the dead bodies of the bacteria also become food for the ants. In this way, the ants continue to reproduce, the anthill continue to grow. The main consideration in the anthill construction are internal ventilation and the temperature and humidity. On these principles, the hot air rises and the cold air sinks. The several ventilation ducts are formed in the interior of allow for air circulation and temperature regulation. The next step is about the growth strategy, mycelium. As part of the bacterial materials, the soil can form sustainable composites that can be cultivated and degraded as a new material. You can see that by reshaping the soil in a step form, allowing more air throughout the growing process, the soil is remodeled and re-optimized, incorporating more nutrients. It is possible for neutral mycelium growth. Degrading the soil will grow a growing mushroom. So, like all the research before, the other scenario is about terraforming with nature. It is still a very preliminary concept. This scenario focuses on land degradation and desertification and related dust storms. And similar to the original strategy of people who use stereo cropping to reduce their dependence and consumption of land, as well as the use of grass grids to solidify sand dunes. Actually, this process is just like the growth house. The grass grids are not only the fixed structure, but also carries our plant seeds that grow and regreen the desert after a few years. So in this similar way, we want to use architecture as a porous scaffolding to load vegetation or mycelium in the host to symbiotically reshape the desertified terrain. And architecture can somehow also capture sand domes to grow as phase change material. And next steps are our simulations.
To generate the porous space, we introduce some new rules. We introduce the randomness of making void space in the energy field. So we can see the white area is the initial no energy grid. We want to build the porous structure. This is about the randomness 30%. So it's not similar to the scaffold. So we test another next. We reduce the grid energy to 10%, and the system generates the continuous internal space like the past. So we can see in the perspective view. So next. And then we improve the randomness to 60%, and the pattern is becomes so weird, and it's like a special scaffold or landscape. So next, we thought the white areas like the void space is so symmetrical. So we next. So we make some different sides of the group, which consists of the voxel, like the whole white area. Now we think it's the most similar to the scaffold, to the porous structures pattern, but if not satisfied, actually there's something wrong in our unit script. So we want to talk to Moose and Alex tomorrow to get some new rules. Cause now we don't know how to which rules should we should introduce to our system. So this is our work we did.
Sorry, can you hear me?
Yes.
All right, look, I think there's a lot of interesting issues that you guys are putting on the table. I think the termite ecology, the concepts of the mycelium, especially slide like also 36 for me is an interesting way to consider an architecture that generates scaffold but also becomes the host condition for other things. So I think that's a nice way that you guys have spoken about not just basically taking the concept of termites and just using it as like a formal kind of way of thinking about it, but really trying to develop a symbiotic kind of ecosystem of thinking about regeneration. And I particularly liked this concept of terraforming with nature. I think it's an interesting kind of hybrid way of thinking about this, because it somehow is utilizing nature as a technology and not considering nature as something outside of technology, right? So I think the issues around the architectural implications that you guys have to somehow push forward is actually, when we talk about life cycles, we generally talk about life cycles of buildings or life cycles of humans, life cycles of, particular kinds of systems. Here, for example, you're going to be talking about cultivation, you're going to be talking about very different ways of harnessing natural properties and behaviors as a way of thinking about sustaining life, right? So, for example, your architecture is not just about deforestation or looking at the, desertification as a strategy that's going to be addressed in a different way. I think it's an important part of the problem. But the solution by itself is not just introducing maybe new ways of thinking about generating forestry. So I think the idea is so when you look at slide 36, if you could click on it, this kind of architecture that's a byproduct of it, potentially, if you just zoom in it a bit. This potential thing on the right, this porous growth scaffolding, this is going to be inhabited and created as a kind of shelter to foster life. Part of that is potentially planting, but part of that is also for example, to be given over for plants to grow means that there is an ecology of farming. There are people potentially living there, feeding off of this. It's an architecture that in some sense is trying to create the capacity for life in areas, to be honest with you, that generally are very much against human life, right? This is not like generic living in the desert. This is more like a very different concept of generating a kind of urban oasis within quite extreme landscape. Even if it's just to sustain a small amount of farmers or so forth, your architecture also has to have this kind of relationship of who's there. It's a cycle of life in terms of production, in terms of food, in terms of other things. So I think that there are those aspects that potentially we have to consider a little bit. Do you guys understand what I mean by this? So how have you guys thought a little bit about how far you want to push this? For example, if you take the classic desertification strategy, the problem of dealing with that is very vast landscapes, right? It's a quite hardcore concept of infrastructure. I like the seed bombing and all of these other things. And I think that there are ways of thinking about these technologies. The question is what we're doing is also introducing new kind of territories, potentially new concepts of settlement or city there. Because particularly for those things to be something that's sustaining life means that people will come. And how are they envisioned to be, right? We talked about the growth house before and other these things. Are they localized? Or is it more industrial in the way that you guys are thinking about this nature? We have to take a position in some sense, Liam's concept of, let's say, Planet City or any of these other things, in one sense are a kind of provocation, because Liam is not so interested in making architecture, he's interested in storytelling. So he speaks about the hyper consolidation of the city, or one concept of the city in terms of Planet City. He will talk about sometimes issues like cryptocurrency or other things and talk about the very different kind of landscape that these architectures have, which have to do very little with humans, right? It's a really non-human architecture with non-human agency as part of it. And that can be from microchips to lithium baths to all kinds of things. Like Planet City is the thing that probably has the most architectural thing, which is more like, I don't know if you like this project or not, but this is more of like looking at Blade Runner and just talking about Blade Runner like 2.0. But actually Blade Runner was very dystopic. Blade Runner was talking about the difficult things around technology or the failure of technologies, making these kind of hyper dystopic landscapes. And the reality of the things that you guys are doing is somehow motivated very differently, I think, from Liam and from, let's say, Blade Runner. If it was a story, it's about survival and has to be developed with a certain optimism. But it cannot be utopian. Do you understand what I mean by that? Like utopian can be like trying to push to make this kind of Garden of Eden where everybody is going to be like, life is a struggle in these kind of environments. So the concept of living in these environments and the concept of mycelium, this will always be like an architecture that's born out of strife. You know, we need to do a little bit of research in terms of the conditions for mycelium, because mycelium also needs a lot of moisture. And so I see some challenges in terms of moisture and desertification. These are not challenges that we cannot work through, but I think there are challenges in terms of understanding like what is the principal material of what our scaffolding system is. And there are some aspects of projects in the past. We used to have a student whose wife invented basically a technology of binding sand with bacteria. Apo, her name was Elizabeth, no? Faisal's teammate, the American guy who was in Sharjah.
Yeah, well, Michael, I remember her.
Anyway, Michael and his wife invented she made it into a company now. They do these kind of paver system stuff. Bio-binding. I'll find a link for those things and send it through to you guys. But yeah, I really don't remember the company name. Anyhow, long story short, the important part about it was, let's say, for example, her technology was really using bacteria as a deposition that would basically almost like super glue in a 3D printer fuse the sand together to make these kind of sand bricks. And this kind of technology would suggest that the existing sand on site with an industrialized process pushed on top of it could deal with this larger kind of sand strategy as the actual container, meaning that there wouldn't be real problems in terms of scaling up. But it would be a very different concept of terraforming, because you would be binding things, and then it would be almost like an archaeology that you would be digging out the scaffold architecture. So the concept of the robots that potentially would bind and the robots that would extract, this cut-fill kind of strategy that we've talked about in the past, this could be a way to do it, but it's not about mycelium. mycelium as a concept for growing, how many, what do you want to use it for exactly? What's your thoughts on this? Guys?
Yeah, actually, we think the mycelium not only can be part of degradation for the material in architecture itself, but maybe just like the ant system, just like that terminate their inner system, we might could use um, the mycelium also as a kind of resources or like a food for the people. So we think maybe it's just also the symbiotic for both human architecture and the mycelium, three of them.
Yeah, I think the only thing we need to speak to is like mycelium, at least in the mycelium research that I know about, is very water intensive, you know, to grow the fungus. Is that not the case? Guys?
Yeah.
What I'm saying is that it's important to...
This diagram depicts a production process.
So I think there's a... Does the chat function work on this thing? No. Okay, anyway, there's a conference called Biofabricate. And I think we should look at it. In 2019, I gave a talk with also the girl that I mentioned who did the sand binding research. So I think you can have a look at Biofabricate and you'll find her name. With the issues of mycelium, we need to know if mycelium is the desert going to be the site, the context in which you guys want to work on? Or is it just one reference?
Actually, we did so many research and we thought our background and concept is quite clear. So now the only thing we focus is how to generate the porous space, the porous structure in our system. But we're stuck in the coding in Unity script, so
yeah, I think
I
understand the coding part. It's more a decision about what kind of context. Like the mycelium concepts, I think, is very interesting, but mycelium as well has a very water-based environment, right? And desertification has a very dry, arid situation. So the concept of harvesting resource would be different. And I think in some ways, we just have to almost take a decision about one of them, to use it as a scenario to kind of test the algorithmic logics, but also to test the concepts of how we are looking at the concept of deposition. So for example, both examples that you're showing of like almost like clay printing or the biosand strategy that I'm mentioning in terms of printing with a binder and using the existing sand of the desert, both of them are additive processes in terms of deposition. The sand strategy has an extractive issue, which I think is very important, that you would have to invent, which is more like an archaeology of a scaffold that you would dig out and another process would start to happen. The mycelium has a slightly different thing, which is, you know, the mycelium by itself has an issue of scale, meaning like The problems that you can address with mycelium would be much smaller and much more dependent on the growth of the actual material and its repurposing of mycelium as a product, right? Like the bio brick, that's like a mycelium brick, or products in industrial design. So the ecosystem that we would be talking about in terms of life cycle would be very different. Now, I think in the beginning of the presentation, you guys talked about these kind of non-human landscapes, in particular with the cryptocurrency and so forth. And I think that these things are also important to look at, because these are territories that people are not really very conscious of. How much energy is taken within kind of digital frameworks and computational frameworks. So for example, this has changed a lot how people are interpreting cryptocurrency and NFTs and things like this. Like NFTs are basically like legal agreements in terms of rights, but they're not like copyrights. And in the art world, for example, different kind of crypto NFT strategies have opened up different conversations about how much communication, how much consumption of energy is there. So for example, one artist, Memo Atkin, basically showed that he could power his studio basically for a year for basically a couple of crypto exchanges on the licensing agreement of an NFT. So what we sometimes think is sustainable with digital culture has radically different consumption rates. So when we think about life cycle and energy and harvesting, of course we can make more optimized cryptocurrency, and that's happening already. But the challenges of what this world would mean if it shifts into this kind of paradigm, I think is actually quite planetary in scale. So to be honest with you, blockchain, for example, is not something that everybody's buying in. Governments are not buying into it yet. But if they did, if you had coins that were backed by governments and so forth, the amount of energy that we're talking about to be running in this way for all of the transactions and all of these kind of online agreements is vast. And this is a world that's evolving in front of us that people don't know. So there is a certain also aspect of terraforming that is happening through very kind of invisible forces. So the reason I mention this only is in terms of terraforming with nature, this kind of new nature that we're talking about. It's important to kind of conceive of what are we really speaking to. Localized survival, like literally having a host condition where humans can sustain life, or more planetary kind of architectural issues, which is more about like impacts of, for example, digital infrastructure and culture. Like there is scenarios that are very Blade Runner-like, but it's not about choice, about leaving the city. It's more about these kind of infrastructures that are making such energy demands that we don't have systems that are able to understand. And so what's the impact of those things? It depends on where you want to go with the project. I think scale and magnitude is very important. I think the concept of scaffolding, I think, is very important as well. Porosity, though, when it's coming to its spatialization, will mean something very different. So, for example, in the stereoscopic planting, I think that there's obviously very interesting opportunities to create, like termites, moist environments, but the scale of that porosity to extract those things cannot just be like take a termite mound and scale it up. So that concept has to be studied a little bit further. There was a research group in Loughborough University, which was basically working on termite mounds as 3D printing strategies. I think Apo would know a bit more about these things. I can give you some references in that sense. But I like the larger scale problem, if you ask me honestly. I think that this challenges our concept of architecture as well. So if I had to choose, honestly, I think like looking a little bit more in depth to these high impacted energy consuming landscapes that are becoming terrains that are based with digital culture, I think is interesting. I also think desertification is also very interesting. And the problem is that even some of these energy consuming landscapes that may be not deserts, the expanse or the impact to the immediate environment around it are so strong that they completely destroy some of the ecology that's there, or that's what's happening. So we can start to think about what are the implications of some of this. But I think you guys can start to look at strategies and algorithmic strategies of termite ecologies so that we can have the genetic kind of voxel-based strategies of thinking about that, and then think about the way that one would distribute that as a subtractive and additive kind of logic. And I think we can push a little bit further on trying to understand a little bit more the terraforming concepts on your side, so that we can maybe choose plausible scenarios as testing areas to look at it, so that we don't do a traditional desert desertification kind of remedial job, or we don't do, you know, a more traditional kind of thing. We start to look at larger, more strategic impacts. So the prototype is really addressing these kind of larger terraforming problems. Does that make sense to you guys?
Yes, that's what we are doing right now. We try to explore the algorithm to achieve our concept. Yeah.
I mean, I think the algorithm, in some sense, should achieve a way of dealing with growth that has the complexity of the intelligence of things like a termite. I think in some sense, the way that strategically it would be deployed, or the way that something like, for example, stereoscopic planting or other kinds of aspects can then use that scaffolding, is a different form of invention, right? So it seems to me like the termite logic is building that porous growth scaffold, but then there is a concept of growth which is not about generating scaffold, it's about generating living systems that can benefit from the scaffold. So I think that there are parallel researches that can work. I mean, I understand why mycelium and this porous growth scaffolding is here, and I think we can make it work. I just want us to be, we have to be aware that the scale of the spaces and how termites work are very scale dependent to extract the moisture out of the air, right? So in a sense, the termite mound creates a lot of moisture internally, even though the outside of the termite mound is completely, you know, sand and desert, right? Extension of the landscape. But it does that through the channeling of all those little airways that capture the moisture for the fungus to grow inside of the termite mound, like we talked about last time. So we have to figure out the scale logic of deployment of that, so that we don't do something that looks like a termite mound by itself, but is really extracting the intelligence of a termite mound for the purposes that we need. Does that make sense?
Sure.
Questions, please? Apo, do you have any comments on this?
I think it's good strategy. I think it's good strategy. I don't have something to say, to be honest.
I mean, I'm thinking that one of the projects would be maybe useful to have a look at in terms of stigmergy is a project that happened in my studio a long time ago, but it was called Farm. And
Farm? Who did that?
it was a kid named Max. Which, if you look in the Adaptive Ecologies book, this was a prototype. This was for housing, but we basically tried to really domesticate a kind of stigmergic model. So this is a kind of cross-section of the housing type, but we tried to really control the agent strategy in terms of distribution to be able to deal with porosity very much in terms of developing housing. So it was very cellular. So we took something like the Corp concept of the Maison Domino as a voxel kind of container logic and distributed a porosity model. But if you look at the Farm project, this was done around 2007. We generated this kind of concept. The concept of stigmergy in this case, I think, is quite useful. But I think the thing that I think is important to consider is that we had these kind of proxy cellular logics to help generate this kind of fusion between voxel-based strategies and agent-based generative strategies together. The stigmergy logics is going to be more agent-based logic because it's about path deposition. And the general voxel-based logic is really about that distribution in terms of resolution space. So I think if you look at it together, there are a couple of diagrams in the book that if I can find them, I will send them to you. I think will be helpful for you. And this, I forget the name of too many people that I had as students, I forget. Okay. I will look for it and I will send it to you. Just check one last thing. But I think that that's a project at least that you can see something about. I think I talked about it a little bit in this lecture on adaptive ecologies. And let me just see if I can find the guy's name. Okay. Ian Maxwell. They sold this model to the Frack Center. Mm-hmm. I think one day I'm just going to make a website of all my old students, see what they've done. You know, I'm looking for the stuff because they used to publish the project on their website. This is new stuff I haven't been on for ages.
Actually, we've read the adaptive ecologies these days, and we think the emotive city, this project maybe could be a good example for us.
You too. It's a good project.
Yeah.
I think I agree with you. I think it may be more useful. The only reason I mentioned the Farm project is more about a technique of looking at the stigmergic relationships. I'm sorry that this website, I don't know what they've done with the older stuff, but I will, if you have the adaptive ecologies, you can see the diagrams of that Farm project. And maybe it's helpful for you. We can always discuss other things as well. But I think the project is interesting. I think there's a lot of really interesting things at it, but I really want us to push some of its consequences also in terms of understanding its scale. Like when we were looking at the Dagon stuff. Apo, you know Dagon's project. Maybe you have some resources of that stuff that you could send them as well.
Yeah. I have some stuff actually. I can probably find the book.
Yeah, if you can find the book and send it to them, I think that's helpful.
Yeah.
So at least they can see some larger scale sand forming strategies. And I think the other book, which I've had a trouble finding, is the Sweatworks project.
Yeah.
So if you find that,
I definitely have that one.
Yeah, I think you can send it to the guys.
Okay.
Okay, guys. I think there's good work, but really push the simulation so they don't look like these little cubes or these little samples of stuff. Let's try to start to look at it more like a landscape. Use the language of landscape in the ways that we're looking at this. Okay. All right, great.
Thank you.
Thank you, cool.
Exciting stuff. I think all the projects super interesting, but also we need to be very creative and we need to try things. We cannot be afraid of trying things. Computationally, you have to really be pushing to look at things as larger fields, higher resolutions. You know. I think that's very important. Okay, can we get the water team?
Sure. Can you hear me well?
Yes. Guys, I'm going to be listening to you. I'm just going to turn off my camera for 5 minutes so I can eat something. And because I have to run off right after this. So you guys present, I'm listening. I'm just going to turn my camera so I can eat in peace. Thanks.
Sure. Yes. So we can start by stating that water enables growth. We focused on this, water as a key to the founding and shaping of cities. The first settlements were established alongside bodies of water. And water strategies always played a huge role in how they flourished. So how much water do we use? Agriculture is actually using the largest amount of water, the percentage of water, with only 20% going to industry and then to domestic uses. This percentage fluctuates according to the countries, to how industrialized is a country or not. So, for example, Belgium has a very high consumption of water in industry. We try to look at this data. So one interesting concept is also the idea of virtual water and how much water is used to produce a kilogram of barley or beef or milk, which is something that we don't see and we don't really understand in our everyday lives. So water infrastructure now is based on centralized systems. Centralized infrastructure is invasive, stationary, not adaptive to natural changes, designed based on abundance of resources, and has a lifespan. We could say for sure that nature changes, and we see that especially water scarcity issues. Infrastructure parallel to this, even in the most developed countries, infrastructure is aging. where many places face polluted water issues. Even in the States, we see this kind of problems. Or India is a good example of that. In general, resources are less than the demand, but we can't be still based on abundance of resources because demand is continuously growing, and we can't restrict that in a way. While water is not accessible and secure everywhere, so we have to reconsider this relationship between resources and demand, how resources can be informed by demand, and we should diversify the demand. Basically, infrastructure needs to be formed for the amount of water needed, the type of water needed, place and time where it's needed, and information technology can regulate this process. So system now is linear and massive. We simply have we go from collection and storage to 2 levels of purification and distribution. Communities should grow within the capacities of their system. However, so we should increase regional adaptability. And we think that we could introduce the water off-grid, kind of personalized water, or water nomads, as we could call that. So based on water collection and filtration. Well, we can understand that as not as a separate thing, but as a gradient of functions, like from water collection to water filtration to water possibly distribution, or at least to water storage. So this could be also perceived as a landscape, as a public landscape. We could think of that as a mess that captures, organizes, and regulates. So it is control, purify, direct. Yes, and we like this. This kind. The following research is kind of schizophrenic, I would say, because we are going back and forth. We are trying to push different directions. Anyway, the idea. Going back to the idea of water as growth, like we have bubble gardens. What if we could have like these water gardens or water fields, which are infrastructure at the same time, collect, filtrate, and store. And it's an infrastructure as community. And here we don't know how to introduce exactly the concept of distribution, which could be the nomads or the swarm agents, the distribution agents. So here it's very important to understand that agents should be informed by the different types of water, the consumption of its household, the type of water and function. There is a question of scale. We question different scenarios according to scale. So we could imagine even like we could go from a smaller scale scenario, which could be a movable unit which collects water from high humidity areas and transfers that to low humidity areas. We could imagine that as a unit that is located in a house, or is localized in a house, or it's like a roof. Or we want a unit that is localized in a neighborhood and creates also a center or something for the community. Or it could be perceived as a skin which is applied in different areas, or even in, I don't know, in fabrics. No, not so sure. So scenario. Very, very diagrammatic. We are trying to somehow understand how this could work. So it could be 3 different layers, a multi-layered material, which like the first layer collects, the second filtrates, and different different type of filtration, and the third layer which stores. And the water storage grows as the structure gets shaped. Could be related to different material, yes. Similar strategies of, or another concept that we were thinking was how to do that also on water and expand land on water. And for example, if we could throw a mess on the water and this starts to gets actuated from the flow or from the water, and creates this like landscape and infrastructure for the city, which works like again with the layers of collection and filtration, and the floating system could be work as a storage also at the same time. So again, as the storage grows, the level that the structure floats is varying or changes. And this could have also different typologies in terms of how land extends towards the river. So where can we locate that? Low humidity, high humidity locations. We were thinking also, we were examining arid climates where there is no water in the air or ground, but this we can't use this kind of climate. We want something in between, and we can. We were thinking this case, Yemen's case, which is a dry subtropical climate with low annual rainfall and big difference in max and mean temperature. So we're like orienting towards like ways that nature collects and redirects water, and some methods of filtration like this method, which is developed by Sealam, which uses a trunk or a branch to filtrate water, or a hydrogel research that was published like before a few months that shows how a certain hydrogel can work also as a filtered water, as it swells water and absorbs the contaminants. I have some stuff like about the material. So we were thinking wine, we could use hydrogel. There are different types. Maybe we shouldn't elaborate further on that, but there are different types, and there is a variation that can also create can create a gradient of properties. And hydrogels, I don't want to speak so much about that. I think we were planning to do some experiments with hydrogels today, since 3 of us, we are in London, hopefully. So, and we saw the rate that the hydrogel expands and how much it expands. It according to research, it can expand like 600 times its size or its weight. So it can work also as filtration, as storage, and as structure. Want to say anything else here?
I think what is important though is beyond just checking what hydrogel is doing and how you can, the expansion rate and all that stuff. You start thinking about how can you utilize it, or how can you push it to its limit and try different types of operations of it. So yes, we know if you take the capsule, you put it in water, it's going to get 20 times bigger, end of the story. But what if it is within, let's say, another material? How is it going to behave? Or what if is pulling humidity from a wet material? What is going to happen? So how those different scenarios work. How does it hydrate? If you put it under quick and intense heat, what is going to happen? So this is what no material will give you any kind of answer to your questions or creative answers to your question. You need to put them in stress, and sometimes you need to go controversial. You know, water and heat. What is going to happen? And that's where it's getting interesting, actually.
Yeah, and this study actually showed that not only they act as super sponge, but also when they are exposed to sunlight, they can release this water. So, but there are so many different types also. So it depends on the type of hydrogel, all these properties that you want to make. So we try to like moving to the computational part, we try to do different examples and to push different directions according to how we could imagine these 4 basic directions, like capture, filter, store, and distribute, let's say. So firstly, we did some Maya.
For this one, the simulation is based on particle flows, trying to say if we put the controller between with repulsion and attraction force, and can try to control the flow with certain fluid patterns. Okay, next page. Next page, please. Yes, it's same logic, but we're trying to say if we use different values with different this one also what kind of pattern we can generate. And when we think about water fluidity with topographic, with the geometry, it will naturally happen in this way. So if we put the controller between, we may generate certain different type of patterns can implement into architecture or landscape.
These are some very similar, how obstacles can direct flow, but just in a different, just in Grasshopper.
And with another type of simulation based on the particle with turbulence, and trying to say, because before we are searching about different phase changing, so it's the phase changing is defined by different by between the particles, and the distance is changed. So with this simulation, we're also trying to simulate this, trying to create volumes and different heights and volume between. So maybe we can see some potential within it.
We explored further the swarm behavior and programming water flow.
So, like, the aim of all these simulations is looking into the flow and the path that liquid takes, and how this could be, like, create either space or create structure or something that is tangible.
looking into the flow itself of water and how we can direct it and how we can see the potential paths that we can create.
Based on the previous simulations and Unity, where we tried to simulate the water behavior, we were also thinking how it could be to overlay different water behaviors, different states, let's say, so that we have like one layer of direction, one layer of filtration, and one layer of storage, which somehow interact also. So these are different variations. We have some experiments. Doesn't move. The experiments with density and viscosity. Why the videos never play while they should? It's very strange. Anyway, we tried to simulate also 3 different liquids with different viscosities and densities and see how one could act as a retention to the other and how could work as a storage. And we found this simulation particularly that it could be interesting because we see how a liquid of higher density and viscosity can hold we actually push this simulation to the limit, and it never penetrates the liquid. So it seems like after the liquid is filtered from the red one, it can be stored, or it can form clusters in the cyan one. We also did some experiments on growth and different types of growth, like driven by forces and restricted by a structure, like a heavier. Imagining that we have a mesh structure that constrains and the softer interior that inflates or expands or grows. similar here. And just trying to control this the way that it grows, but we can do further on that. I mean, we could control that more. And these are some experiments on more in infection logic, where we test the two different surfaces, like a bumpy surface or a smooth surface, and how a growth can, how we can control the rate of growth here. The final part is how whether we could also consider the distribution and use a swarm system to distribute water to a household or to individuals. So we could say that we have three systems, like a flow system, which is based on swarm, which is basically harvesting rain and atmospheric water, moisture, and is more is capturing and filtering, basically, and growth system that is stores and grows, stores and grows, possibly hydroponic farm, and also acts as a garden and a place to meet, or an ambient place, and the distribution part. And then we don't have something very specific, but we were just wondering how humidity affects sky color and how temperature could be related to, we have different color temperatures throughout the day, and whether how light gets infracted through humidity. Yes, we could use that in order to create some ambience or to relate that to different amounts of humidity. This is from us.
Okay, guys. I think it is at the moment a bit of a collection of stuff. And I think it's important also to not lose sight of the fact of all of the teams, honestly. Phase change in your research, I think, is really primary. And honestly, in this presentation, there hasn't been very discussion about that. It's mostly to deal with an interpretation of flow, which in some sense also is not very clear, because in some ways you're not using abstraction as a way to have, let's say, a multiplicity of readings of that word. You're somehow using the simulation tools almost to mimic flow-like behavior. And I think that there's a big difference between things, because I feel like up until the presentation, and don't get me wrong, I think that there are some, I think, very interesting kind of computational experiments that we can leverage for these different things. But I want us to be kind of clear, like, let's say, for example, force-driven growth, I think, to be honest with you, should be conceptualized much more from the phase change capacity of looking at its formation in terms of crystalline structures in ice, rather than just leaving it there as something that is just another experiment. I think they need to be reformulated in a way where these experiments take on board, I think, really phase change as the primary discussion. Because also you imagine that a lot of the research that you did earlier on hydrology, on terraforming and the channeling of water and all of these other things, we were always looking at water behavior, phase change behavior. And I want to say that that's kind of principally where I see basically most of the investment in the project necessary to go. That being said, while you guys were talking, I put together a couple of references that maybe are useful to have a look at. I don't think any of them in particular are your project, but like Apo was saying before, like moments that can be captured, I think are important to kind of articulate. I'll say this, I mean, there was a kind of generic sketch diagram, which I should not use the word diagram, illustration sketch, that basically said the relationship is kind of like an interface between land and, let's call it sea, or land and water body. I'm not sure that that is what your project is either yet. And I don't want to somehow remove, you know, first attempts of talking about what architecture is. But I think prototypically we need to really, like, if I look at that as a sketch for architecture, it's very problematic. And it's very problematic from very basic things. For example, it's a retention system, but it has no migratory or irrigation strategies to get the water somewhere. So it's retaining water, not necessarily in a place that it's needed. It's extracting it from someplace and it's storing it. But these things start to happen in terms of channels and all kinds of engineering dominated ways of basically giving access to water, rather than thinking about harvesting as being an extension of this hybrid architecture infrastructure. I'm going to share my screen for an example that was working similarly to what you were sharing. I don't know, I think we talked about this project before, no? Think Tank? Have we or haven't we?
Haven't talked before.
Okay.
I think we discussed it roughly. I think they just didn't get it, Theo. I think we discussed it though.
No, it's no problem, and it's not something that's super critical, but there are some techniques in the project which was very formally technique driven on a micro level, which I think are interesting that you guys can look at. So this was a project that was developed in Rob's studio, and at the end, the application was really like generating a roof structure. Now, in terms of its architectural implications, I don't think it's very important, but in terms of translating these kind of micro ridges in a way to control water, I think that there's a lot of things that you could potentially look at in terms of techniques, in terms of vector flows, and in terms of translating some of this into, let's call it water management systems, for lack of a better word. So I think, let's say, a concept of looking at this from a systemic point of view, regardless of the actual articulations of the different kind of flocking strategies or flow field strategies on the surface, I think there is elements that are correlating, you know, flow and curvature. This could be of existing landscapes, or this could be of your generated kind of architectures, to be able to migrate and distribute. So this kind of concept of venation, like distributing veins, and this concept of capillary, I think is quite useful. And I think even the techniques of ridging, I think, is important. So even if, for example, the morphology of this geometry is the same, the way that one introduces ridging patterns would actually have variable ways of thinking about how water retention or collection would be. From a material level, I thought that this project had some interesting examples, which you don't see in the renderings, but there were a series of examples of trying to think about different kinds of materials that had, in some sense, the capacity to expand beyond each initial state and have to deal with different kinds of pressurization to be able to manage that. So the hydrogel, in some sense, is a reactive strategy, which basically deals with changing of volume to deal with the water retention. These kind of diagrams here, I think the points are basically where the capillaries are. It's not rocket science. They're at low points, but the ridging trajectories, I think, is important, because I think that sets up a very different kind of idea of what the concept of venation is. And even the concept of materiality in your case, I think you guys can start to think about, here they try to do a series of simple castings, translating, let's say, a CNC into a strategy that they could basically build an operable surface. This, for me, I think is just examples of some kind of techniques that you can look at on a local level. And I say that on a local level because in some sense, I see this more like an extension of the landscape. Other things that were a byproduct of these kind of particle-based trail trajectory things, if you look up some of the projects that Yaya Kusima has been doing, she was doing it in the late 70s, but more recently anyway, she has been deploying them in the botanical garden here, called like Narcissus Garden. The way that they install these things, they basically just drop a series of spheres in the water body and they start to self-organize and they change and they move. This has no control logic as a byproduct of that. But there are obviously other versions that have control logics to it. I'm going to give you another example. These are within an existing water body, but I don't know if you know this installation by Christo, but he basically just created a path in an Italian town to connect to an island. And it's really like a glorified pontoon structure. What I think is interesting to have a look at is if you took like something like Yaya Kusima's strategy, which is very informal, and you look at the process of Christos, which is a series of aggregates as flotation devices, its organization can be Yaya Kusima, or like lily pads that you're walking on, or can be organized using packing logics to be able to create, let's say, different kinds of planes of reference. So in a strange way, the size and the scale of this particular project is mitigated by the fact that it's a packing system and it can change the surface area to induce basically stability. And I think this could also be an interesting project for you. We'll leave the Bruce Lee for the last to bring this session to a conclusion. I showed Tokojin before, and the previous team was talking about scaffold, and I think this is useful for them and potentially useful for you. When we're dealing with water bodies already start to create natural vitrine situations. And I think that you should consider that aspect as well. You were talking about the desalination aspect at one point in time and other kinds of material attributes. Now, this particular process is a chemically induced crystallization, but this could have just been strings in a glass of salt water to achieve basically the same thing. So he made this kind of chair in the vitrine. There is something to be said also about these discrete elements that can start to fuse. If this was hydrogel or if this is something else, the morphology of the chair is not important. The idea of looking at a water body as an existing vitrine deals with pressures and thinking, I think, in a radically different way. So if this thing is on an existing water body, it has certain opportunities. If this thing is interfacing with land, it has different, needs and opportunities. Or if this thing is actually not on water at all and is introducing water as a mechanism, has also, a different kind of attention in terms of where those things are going. I pulled up Alex's project, Alex, Georgia, Lisa, and Susan. because they did, I mean, Susan in particular and Lisa did a lot of studies on soft robotics, but they did a lot of also really interesting work in terms of just trying to set up simple experiments to kind of evaluate. So this kind of language, I think in particular, in terms of setting up, like each one of these things by themselves is not interesting. It's only when you see them as a kind of catalog of very simple examples and you kind of see it as something that's time-based that you start to appreciate other qualities of things. And I can tell you which ones I found most exciting was not this kind of beating of stuff, but there are these moments of the spherical packing strategies when you introduced a skin or a lattice or something to help give form or constraint to these loose particles. I think that's important. There were also attempts, for example, to just like introduce latex or whatever. So when these things started to shrink again, you started to generate porosity within a negative because the cast of the void former was basically changing shape as the dissipation of water left the hydrogel. Why am I saying these things? Because this was a kind of search space, but what I think these guys did very well, and this is really primarily Susan, was she was just in a quasi-scientific way, always photographing every experiment, always formatting everything so that there was a relational capacity to the experiments. And it gave the project a kind of language. And that became important later on. It didn't seem so important in the beginning, other than, you know, quite beautiful images and so forth, but it became important later as a methodology of, you know, these don't look very different. When you look at it closer, there are really small differences. Some may be in the material thickness of the cross-section of the thing, some may be in the size of the chambers, and it started to play important aspects later on in the project. So I'm mentioning that mostly because I think this is a good example of looking at something like this and really saying, well, what if this was actually the physical material of our building? Right? This is hydrogel now, and it's a messy hydrogel with remnants of, you know, latex and other things on it. But you start to see, like, even those things that are absorbed in the system start to become something very beautiful. And when we started to work on this kind of project, we saw it basically as the interaction between two agents. So there was a growth logic, and then there were these kind of worm-like logics. And the whole dialogue was really between those two things. But I think maybe this isn't a bad project. I don't think your project has anything to do with soft robots or any of that stuff, but you guys also have a graphic language in the way that you present the work. And I think that there is an affinity there. I would just start to look at something as simple as organization or body plan. I would start to organizationally think about the formational aspects of, let's say, the force-driven work for ice and all of these other things, versus, I think, salination, crystallization work, or the strategies of flow and particle that you guys are doing, because I think they will give us a very different way of thinking about space-making opportunities. If we jump too quickly into that sketch section that you guys did, the project becomes very, you know, Patrick would say very engineering, which is not really about infrastructure either in the context of our studio, right? Do you guys understand what I mean by this? Or am I confusing you showing this project?
Yeah, sure. I mean, the sketch was very early. We don't expect that it will be like that. It was a way to somehow visualize an idea.
And I don't think that that's a problem. I want to see a lot more of it. I think the problem is if it becomes the only one and we get stuck on it. So like I've mentioned to the other teams, I think it's important that we somehow tease out, like, what is the possibility of this? And because scale is something that you rightfully talk about, in terms of this presentation, some of the introductions, aside from the digital research that you guys have been doing, like the algorithmic research, which I think has moved along quite well, the only thing that I would suggest is that we don't treat things in terms of like a clear stratification. So for example, with the particle beads, where we have them, you talked about them as 3 different and distinct layers. I would allow that permeability or that porosity to migrate between the things. The difference between a loose particle that is an agent versus string behavior that's following a very clear path. So that we introduce deviation, and then we also introduce the concept of this multi-mixing strategy, because we don't know explicitly what each of those layers primarily is going to be conditioned with. Part of it is material logic, but the other part is really in terms of intentionality of things. So I think that there's a lot on the table, and I think you guys have, I'm very happy to see a lot of the digital work being much more experimental in terms of trying things. But I do think that at some point you guys are really talking a lot about visualizing flow. And I would really like you guys to bring back some of those other phase-changing aspects that you already are doing algorithmically, you just don't declare it. And the most simple one was the force-driven work that you mentioned. Does that make sense or not?
Mm.
What do you think? Well, I will get this stuff off the screen so we can see each other.
I think it's true. Like we have to go back with the phase change and like look at like personally, like it would have been better to see like the different systems for each phase change and like actually translate that into what our spaces could be. It's just we struggle how to translate that, and like in terms of what we did with the diagram, the sectional one, it was just one aspect of a system of taking water, collecting water, and just actually actuate an architecture.
I understand that. I think the thing that and I don't have a problem in you guys doing those. It's not a protective thing that I'm saying. I think we should expose it, and it's a messy process. And we do that, the more that we do that and the more that we iterate, the closer we'll get to answer those questions. So if you ask me what was the right thing to do, the right thing to do. It's just what I'm suggesting is don't try to shoehorn everything within one way. So if I had to hear the clear messaging of what you guys presented, it was very flow field oriented, path oriented, while a lot of the other research, and it could be that this was just a moment in time. And if you contextualize it in that way, that's fine too. We're going to take those decisions. But at the moment, because of the scope of some of the algorithmic processes, it's more about just giving legibility of the opportunities that you find in growth. Like if I asked you what growth means to your project, that should have very particular implications to water as a material. Means something in terms of what that means versus flow. So water as liquid versus water as ice would have very different concepts of growth. Actually, water as liquid, I wouldn't say has growth as a logic in it. The volume of the water will be the same. Its distribution will be different. So we would have different concepts of growth that would necessitate a different meaning of it. Some of it may be more legible than others. I'm not sure growth is the word that I would use to somehow create the umbrella for each of those things, right?
Yeah, like we were looking into harvesting, like in general, we were looking into harvesting water and collecting water, and like the straightforward thinking logic would be flow. That's why we went through that process.
Flow is one way, but some of your earlier experiments was really just changing things using, like the textiles that you're talking about. we're really extracting things out of air, right?
Mm.
It's not really flow. Flow is a second-hand aspect of it. The harvesting part was just basically forcing the change from vapor to water.
Mm.
So it's more about where you put the attention in terms of that. Yes, of course, then they flow and they can organize any cluster, but the main thing was the transformational aspect of taking something from vapor to liquid. And the other things that I would say is, you know, for me, when you guys started to talk about virtual water and things like that, I thought that this was also very important to speak about. I mean, we talk about harvesting and we've talked about the limitations of resources. What we don't talk about is the behavior of human use on these things. So giving legibility to that, I think, is very meaningful. Tying it in terms of the thesis argument, super clear. Integrating it into the way that your architecture behaves, not clear, meaning it's not a one-to-one correlation. So I think you guys are on to looking deeper into some of these things. My only point is not to lose sight that I think phase change is the primary feature of what you guys are really working towards, because I think that's really at the heart of where materialization will find novel ways. Like the same way that we said, like maybe controlling the weather, you know, like a cloud to move water and all of these things. I'm not suggesting you literally do that, but I also have to be honest, I'm not suggesting you don't do that either. It's like we should leave on the table a concept of architecture that foregrounds phase change and is just trying to really think about water management to sustain different kinds of concepts. And you're not going to have all the same definition about this. This is clear. This is definitely going to be messy. You may even say it's frustrating at times because you don't see literal progress in one level, but then you may see a lot of progress in something else. So the computational work, which is really taking incremental development, I think has moved quite well. The conceptualization that has to happen now in terms of what architecture is for you will be a continuous struggle until we start to really start to see formations that we feel are more legible. You know, if we turn it into a Christo project and it's just tiling and occupying a water level, that wouldn't be very satisfactory to any of us, I think, right? But if you think about it in terms of access, if this is on water, it's just a very small component of something much larger. If you take the opposite extreme, that you're harvesting water in areas where water doesn't exist, that means something different either, altogether, right? So we're not clear about that yet, I don't think, between yourselves or myself. And I think that's okay. So I would be pushing much stronger the computational work to be clearly articulated within the phase changing brackets and really forcing yourselves to think about concepts of actually just thinking about how this stuff will really offer some possibilities. Okay, I need to step away. Apo, I made you co-host to continue with the guys. And
can I say?
Yes.
But I think that we agree that phase change, like the previous computational framework, was a failure. I mean, it couldn't work. So we had to push other directions.
Yes, I don't think that's a problem of what you've done.
I mean, the flow is basically the think tank is basically exploring this Schwann behavior, trying to direct the flow. So this is what we were trying to do in the first part, because but it's still in the beginning. Would it be meaningful to explore that more? Because if we explore that, it could be a formational process, because phase change cannot be a formational process very easily, because we've worked so much on that and it didn't arise. So we can't. We thought that it's better to just use that as a mesh and say that a mesh which also can direct flow, or which its shape is formed by the direction of flow, is capturing vapor and is forming that into water. So we don't leave phase change. We don't.
I understand that, Daphne, and I understand why you did what you did. My point to you is that it may have not worked yet. Give yourself the space to be able to revisit things instead of closing them off completely. And that's why I'm saying the researches should be bracketed in ways that you can revisit and reconsider their appropriateness or usefulness, because it's not 100% explicit. So yes, of course, you can continue down think tanks line, and I don't generally have a problem with it if that's what you really want to do. But there are obviously very serious issues about think tank, which is think tank was a pavilion. So at the end of the day, they were just talking about shedding water off of the roof and collecting it in areas. If we look at the scales of the problems you guys were looking at, they were much larger. So terraforming a landscape to basically channel water by itself, I'm not sure that's the kind of project that you would want to do by itself. So though it may be an aspect, I think prototypically you can work on it without declaring a scale, but just to look at curvature and ridging to find it as a control mechanism to coordinate water. So for example, you capture it in a textile that's just an open fabric, you channel it in a place where you're trying to get the water to collect. That's where venation and capillary, I think, are the interesting aspects of what the kind of hybrid textile hydrogel conversation we had last time, which is not what think tank did. It's just evolving that language and pushing it in a further trajectory that's yours. So I think that those are going to be happening prototypically. I apologize that I have to step away, but it's time for me to go and I'm already very late. So, I mean, we can continue the conversation on Tuesday when I'm back in London, if need be. If you guys want to take a couple of days to think about that stuff and we meet again, or if it's more useful to do it towards the end of the week, you guys let me know. So you continue with Apo just to get his feedback on this. And I'm available on Tuesday, like I said. So we can have a shorter session, not to revisit all of that stuff, but maybe you guys can have a moment to think about these things, our comments today, and come back with maybe like 4 or 5 slides that kind of bracket what we've talked about. Is that okay?
Okay.
Okay, guys. Apo, I'm going to leave you on with them, okay?
See you.
All right, guys.
Thank you.
Yeah. Have a nice day.
And the projects are cool. They're slowly getting there. This will be the term where we actually make this stuff happen. So we're going to invent it. Have some confidence. Don't be so frustrated. This is going to be creative friction as the way that we conceptualize this. And Apo, you can play the Bruce Lee clip. I saved it, but it's too late for me to play it.
Okay, that's fine. That's fine.
Just let me have my little moment of cultural appropriation. Bye-bye.
Bye.
Hey. Okay, so guys, I don't know if you have any battery left on you.
Sure.
Well, I don't, but I can keep going for a while. But I don't know how I can help you now at the moment. It's like, you want to discuss something?
Like, what are your thoughts about what we presented today?
Well, now that's a big one. I think it's moving towards the right trajectory. I think, as Theo said, it's too many things scratching the surface. You just need to dip into some of them, I think. And I think it is very common and very normal to be frustrated at this stage. I guarantee you won't be less frustrated next December. It is the process, right? And then there's a moment where you say, this is it, and it's finished. It's never going to end. You know, it's part of the research. So, I mean, you shouldn't be concerned about that. I think what you should be more let's say, open to is this kind of exploration and trying to effectively mix things up to get the unexpected out. I think this is what you are actually a little bit afraid of doing. I think get the unexpected out. Do the mistake. This is what that's gonna give you the twist to invent something. Let's call it. If you try to do what you know, nothing's gonna come back. Yeah, I mean, it's gonna. You know what's gonna come back. Actually, the one that you actually expect to. But if you shake things up, you may get something out of it. You may not. If you don't, you change your strategy. If that makes sense. But I thought you had some good stuff to do. Which I know it is painful, but you know it's. I think it's good. Yuki, you're not mute. Yeah. But you really need to play with it. It's just putting it in water and looking at it getting bigger is not gonna give you anything than what you expect it's doing. But once you put it together with some silicone or some latex or something else, then it starts changing. So this is all I can say for now. If there is difference, well, we are working in a different condition now, right? We are not in the studio, and the studio is actually much more encouraging those kind of things. It's not that the other students at that moment they were like 100% there. They had all the prototypes, and it's not like this. All the work you see, it's usually a year and a half's work. It's not the first term, right? What Theo showed you with the research from XO is not the first month or two, it's the whole year. So it's not that you are behind as such. And if you compile all your work, I'm telling you, you have quite a lot of stuff. The thing is that you just need to pick the right ones and explore them at this stage. And we don't know what's the right ones. That's what the problem is. But once you take some decisions about what you are researching, let's say, or exploring, then this is gonna get a bit more natural. And you are 4 people, so you can take different avenues.
Yeah, that's what we tried by dividing like the research in 4, like direction, growth, and filtration.
Yeah.
And then distribution, which we didn't explore much. But isn't it a good way to think about our project in general, like, and some dividing that in these different directions?
Well, the thing is that at the moment you just attack, right? You don't know what is gonna work, so you can have different streams of research, right? Some of them will not work, I'm telling you. So then the four research streams are gonna become 2. And then you're gonna start combining. But because you're in the beginning, you need to explore as many things as possible. And the more you put up in the reviews, the more you get comments and directions on. And then that takes you to the next one. But there's no one thing you need to do.
Yeah, I agree. That's why we tried to take different directions. But we feel that we're not we're not receiving a feedback to that. Yeah, I don't know.
Well,
a clear feedback, so we don't know again how to push that forward.
I
don't know.
It's difficult to say, but feedback is not that straightforward for anybody.
No, it's not.
Is when you ask a question. If you ask the wrong question, you're gonna get the wrong answer. Although the answer to the wrong question maybe is correct. So all I'm saying is that depending on what you put on the table, you get a similar feedback, but it may not be helpful because actually what is put on the table is not the right thing yet. But that's fine. I don't think it's a bad thing. It's just it requires, let's say, repetition and how can I say? Well, moving forward effectively. I have a feeling you are a bit too frustrated, and you're more than you should. But and I know you're doing a lot of work, but it is what it is. But don't feel that other years were better than you. I don't think so. Yeah, but usually what we do when we do the Arduino stuff, it's in November. Because students, they don't know what they want to do till then. So I don't think, that's what I'm saying, is what you see, it's a year's work. It's not a few months. Because if we were able to say, this is your project now, what were you gonna do till next February?
But aren't we supposed to get, like, at the end of this term, like, actually define what is our project?
Yes, that you need to do. And I think some teams start getting it a bit better than others, but you're gonna need to define what is your brief, what are you working on, what is the main research, and what is your material, perhaps. This is the things you need to explore now. Now, in other studios, you may see more architecture, but I'm telling you, architecture is easy to do, right? I mean, you've seen what is the architectural product of previous years, right? It is something. This something is not, it's irrelevant. I mean, what we are interested on is actually the process and how you generate your, how do you generate your, the system? What is gonna look like? It's the least interesting for everybody, is presentation effectively. So I wouldn't be worried about it at this stage. And the Arduino stuff, when you come in London, you're probably gonna push it a bit more.
We are.
Yeah, well, true. Yeah, I'm taking it back that when you are in London and they open the school, then you may be able to push it a bit further, but I don't see why you cannot start preparing for that already, because effectively what the school is going to give you is a few laser cutters and a few 3D printers, and that's all, right? Nothing is going to go faster than that. So you can start preparing for this, and you already can use the laser cutters, right? So
yeah, we're planning to do that next week, but we would like to know what we want to print.
Exactly, that's all I'm saying.
We wanted to print already this week, for example, but we didn't know what to print. So we want just to take a few, like, to be more specific, to know what to choose from all these.
But you know what? I mean, if you ask that to Theo is going to say print everything, right? Because you print the ones you think is useful. Nobody can tell you what to print. There's nothing. It's not that you print something and you say, okay, this is the final piece. No, because you take that and you use it for something. And the more you print, the more you're going to end up having at the end as a physical model. So if you have 20 things that are exactly the same, don't print all of them, obviously. But if you have 20 things that are all different, I would say print everything. I mean, that's where, I mean, of course, you need to consider, you know, expense and time and effort and all that stuff. But the more you do, the better.
Not always. Sometimes it's better less than.
Well, that's a big discussion.
So maybe can I ask for some specific, like what we were thinking to print? For example, this thing, we did that initially. We drew this results from the flocking behavior in Unity.
Yeah.
Which is also related to phase change. I mean, this could happen here. And we were thinking just to overlay different time frames and to print a prototype which shows that.
The question is, even if you print that, first of all, you don't know how it's going to be printed, right? It may not even be printed. I mean, from what I see here, the majority will not be printed. They will.
We tried that's why we tried different representations. We can solve that.
Yeah, okay, but so the question is whether you print one or two. Or, I mean, what is the question? At the moment, what I see here is one thing, right? So what is the question? Whether you are going to print it or not, you can print it. I don't know how it's going to be helpful to you, but
yeah, which could be the most. We are trying to think which is most helpful to print. As an example,
we were
to create a mess from this. I don't know. Sorry,
but those ones are representation at the moment, right? It's an image on screen that shows what you're trying to do. Any of those, if you print them, they will be similar representation in a 3D world. It's not gonna change dramatically something, right? I mean, a 3D print effectively, if it's not something performative, something that you put on a prototype and then it has an operational function, it is just a 3D representation of the same image you have on screen. So it's not gonna dramatically change the path of your research. It is good to document, and it's good for your final presentation that you are gonna display all those things, and you can have it's a model. Somebody can grab it and actually look at it. Beyond that, and you yourself as well, but beyond that, it's similar to capture it on screen than printing it. Not for everything, but the majority. So if it's not something you want to experiment on, or let's say, for instance, the one you are showing me with the different colors, right?
This one?
Well, similarly, what is that? Is recording the trails. I get it. What is the different colors?
We were thinking different materials like hydrogel. If we can.
Okay, great. So if you print it in a multi-material printer, which they exist, and you have different, and you apply different textures, different properties to it. So one is more elastic, the other one is more rigid. And then if that is intended to be a structural system, right? Then these properties of the 3D print, it may help you start understanding how the geometry correlates to the structure, for instance, right? So this is a model that is going to help you understand how geometry relates to properties and structure. Now, depending on what you want to achieve with this model or what, there are different ways to evaluate them, but this particular one, it will be representational, right? If it's something more than that, we can discuss it.
Well, we were thinking, for example, in this, in general, because the previous part of our research, it was the gradient materiality. and how we could introduce that as different phases also. But this, we couldn't think how this could be useful in a concept. So the next idea for multimateriality, it was this, that could act like we could use the same way that we said here, that we have different viscosities and materials. So we have the very light one, which is melting, and the one that is filtrating, and the one that is doing the retaining. It could work somehow similar here. So
But
this
the
was
thing
the
that
idea in here, that this is, yes, the one
this
is
kind of a
flat.
this kind of a filter, effectively, what you do, right?
Sorry?
It's kind of a filter, what you have here. That's what it's doing. It's a multi-layer, and is acting as a filter, if I understand correctly.
Yeah, it could act as a filter and a storage. So the final layer could be a storage.
So if you want
this
to do
could be
something,
storage.
if you want to do something that actually has a meaning to what you're intending to do here, you actually need to think of a model which could be partially 3D printed, partially using hydrogels or whatever, that has this, that tries to do this performance, right? It is actually, you take it and you pour a little of water, and you see what is actually absorbed, what is filtered, what is whatever. And then you get some mud water and you do the same, and you test how it reacts, right? This is a reason to print that model and say, look, I'm going to test that, that, and that, and I see how it works. If you print that with these colors as a representational model at the end, that you can graphically say, okay, the green ones is hydrogels, and then the white ones is that, and the red ones is something else. It could be, and somebody would say, now I understand the geometrical configuration of those elements together. But if you actually use it for a test, for trying to see how it actually works and whether what you simulating works in real life, it's a totally different story, which I think is the second you need to do. You don't try to do representational at this stage. You're trying to do performative.
Yeah.
But think hybrid. Everything you do, think hybrid. Like, how can you put different materialities together? As single materials, we always know how they work, right? Multiple stuff is actually what gives you the richness. The only thing we don't know, well, we don't know many things, but when you use one materiality, what you actually can play with is geometry, usually, right? So let's say you have a 3D print, right? If you print a solid bit, solid 3D print block, you know how it's going to work, like a solid surface. If you start introducing porosity, then you start giving it properties, and the way that this porosity is designed, or the spacings and you know, how dense, how filigree is, and all that stuff is going to give you different properties. It may become elastic. It may become, you know, it can be act as a filter. It can act as a light diffuser, anything. But geometry there plays a role. So there's no when you use single materials, actually you can play much more than geometry. If you play with multi-materials, then you start adding properties. You're doing composite stuff that they act differently, and each layer of material actually adds to the overall function. And I think this is how you should be thinking here. Now, the key problem is the design decisions. What are you designing with this system? Because it's not that we told you need to do the most advanced filtering system, and then you try to find out with different materials how to achieve that. It's actually how you utilize that to make architecture out of it, which is a bit more difficult question. But it's going to come up. I mean, it's work in parallel. It's not linear. It's not that we need to find what you're doing and then start discovering the materials, and then when we see the materials, let's do this design and then resolve the details. is everything together. And one day, everything's going to come together. I mean, that's what all these years happening, right? I don't see why your year would be particularly different than others. If makes sense.
Yeah, sure. We don't think that it will be something different. We're trying to find how to push further.
No, it is tricky. I agree. But what do you think is the strongest bit of your project? What do you feel excited about?
Honestly, the phase change part.
Phase change is one important one.
Honestly, but with which part? I mean, phase change, we haven't explored that really. We explored the model that didn't work, wasn't helpful. So in terms of simulation, we haven't really understand phase change, I feel.
But are you talking about only phase changing in terms of liquid to air and to solid?
What else?
That kind of phase change, you mean?
Yeah.
Because let's say water becoming captured by hydrogel technically turns into solid.
Yeah, that was the idea that, for example, in this one, the last layer could be hydrogel, so it could expand as it stores water. So we could have something more, I don't know.
Yeah,
something
but
that
then
looks
the last
very different.
Simulation, the growth one, like the one in the structure, like this one, like we're thinking of how can hydrogel be embedded as part of the structure, for example, and once there is ring coming down on the structure, it starts to grow.
How do you produce this growth here?
It's volume advection. It's expansion, basically, but it is disturbed by noise.
Yeah, but that's all.
And it's also driven by geometry, by curvature.
This is technically kind of artificial, right? I mean, it is a simulation of something completely artificial.
So it could be, we were trying to think how, like hydrogel simply expands. So how we could
exactly, but that's exactly my point. If I tell you, get that one, make it in a physical world, I guarantee you're not going to be able to make it, right? But that's not a bad thing, because you're going to make something similar, and you're going to try to find ways to make something similar, which is what we are looking for. We're not looking to get that. This process, that's why we do simulations and then physical experiments, because those two, they're not the same, almost never, except if you do something very specific, which we are not interested in. But by trying to do this, you're going to invent a material way to do it. And then that's going to feed back to your simulation. And that's the interesting point.
Okay. Like, yeah, we were thinking like simulating something and then experimenting with it. Like we have the hydrogels, we just need to know what are the other materials that could actually perform. Like again,
nobody can
push the hydrogel.
You start exploring. It could be silicon, it could be latex. But the question is, even if you get silicon and you say from now to the end you work with silicon, the geometrical configurations you can have, it's so many, that is another beast. So the material after a while starts losing the importance, because actually the design of it is more important. If you use silicon or latex, it won't make a difference. If you use anything like kind of elastic, more or less is the same as the properties. Of course, they have differences, but this is about optimization. It's not about making a system work. So if you're looking at this kind of expansion, what is the ways to achieve expansion? And then hydrogel is the expansion medium. But what is the skin? And then it's endless how many things you can imagine that could be. And this is where you start. I think from all the stuff you've seen, phase changing, it actually, the most interesting bit that you let's say concluded through phase changing is the hydrogel inflation. Just focus on it as much as you can until you say, okay, that's it. There's no more to do. It doesn't work. We need to do something else. But this is part of the research again.
Yeah, the idea, for example, here was that we don't want to reproduce this specific kind of growth. We were just trying to articulate that we need a relationship between something that grows, which is the storage, and something that is a structure. Mm-hmm. So we need to design somehow the growth of it, mm-hmm. and also define what is the structure. An idea, for example, would be that the structure is defined by these flow lines that create or from a swarm system.
But I think, well, the structure is do you mean structure like literally structure of a building? Or you're talking about organization?
Yeah, it can be an exoskeleton, like a structure, a mesh.
But I'm telling you something else. You have a flat plane, right? A flat plane of silicon that has these hydrogels attached to it, right? Once you put water on it, they start expanding. What's going to happen to the skin of this silicon? It's going to start deforming, right? So the way you place those hydrogels is critical to actually organize them in a way that once they expand, they actually create architecture, create a kind of a canopy, a wall, a floor, whatever it is, something structural. And that's where architecture starts getting generated, right? And then
this was the idea that we were trying to show here, but it's not very clear.
Yeah. All I'm saying is that once you start, I think it's the digital world that sometimes hits you hard because you don't feel it enough. There is a high chance once you start trying to do something like that, things will unlock and more ideas will come. But it's actually, it was always, I mean, for me, when I went through DRL, it was exactly the same. You do something digital and then you try to find a physical way to do it. And that's where the ideas are coming. Because for good or bad, we are living in a real world. That's why I prefer to work with real stuff rather than digital stuff. But other people disagree with this, but that's what I would suggest you do, though. You try to build some of those simulations in real life.
Yeah, I think it's time for that.
Yeah, and once you do it and they fail, and there's no other way, then we can rethink some stuff. But since you do that and you experiment with different kinds of setups, materials, then you already will have some stuff that you'll see that it will progress. All the things you see in these books that people did over a year, don't take it too seriously. Like the majority of it, if you see them in real life, it's garbage. I don't want to play them down, but effectively, they're not all working. It's not every model important. It's nice pictures. And the nicer pictures have a bit of color, they do a little bit of more funky stuff, and they are more attractive, but that doesn't mean they are all valuable. So don't get stressed about, okay, the other guys have done so much, we haven't done anything yet. I think you can actually start pushing it. And hopefully from summer on, things will be better here and you can crack on full on. You're going to get sick of the studio, I'm pretty sure, at some moment. We all did. So. I know it sounds weird, but it is. It happens.
I mean, we have a few months left, like until January next year. So
3-4 months is great. More than that. I know it is very controversial times, but it is what it is. You know, it's not just you. it's all of us. We are all like that. We are all in the same boat. We all struggle. And it's not just about AA. It's about everything around us. It's the only thing we can do is help each other go forward.
Yeah.
There's nobody that is in a better place. So. A bit better. Anything else you want to discuss? I'm literally brain dead. I was never expecting it's going to be that long, this session.
No.
Thank you, Apple.
Thank you.
Don't worry.
Thank you.
And talk soon, I guess. And watch this Bruce Lee thingy. Theo will ask if I saw.
Yeah, we've lost that.
Say to him I saw you.
Yeah.
Okay.
We are one.
Okay.
Yeah.
Cool, and keep going. I'll be actually in Greece next week, so I'll be away from London, but we can probably talk over the phone. I'll be on holiday, so it gives me a bit more time to not do work stuff, so we can speak.
Nice.
Yeah, I need a bit of. I haven't been there for 10 months. I'm just start getting a bit cuckoo. I almost compare it like climbing Everest, right? The last 50 meters is what will kill you or you're going to succeed. That's how I feel. I have 4 days to go. And I'm like that. If I manage to go through these 4 days, I can do everything, but it's impossible.
It's a good period now because everyone is more optimistic. Like previous period, it was not nice.
Yeah, I can imagine. Well, I hear the same.
No, because people, I mean, more or less, but like a political situation and economy was
messed up.
Much more unstable.
Yeah.
So everyone was like very, very crazy.
Let's see. Yeah, well, let's see. I don't know. I hope it's good weather. I really need it.
No, it's good.
Yeah, exactly.
Everyone is happy.
Exactly. Because this misery out here, what the hell? And the whole week is going to be like that. Anyhow, I'm talking too much now. See you guys. And,
see you. Thank you.
Nice to see you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.